And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless. For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Okay, we're live. Welcome to another edition of the Supernatural Science Challenge Show. And this week we're going to do an informal discussion with NephilimFree about various worldviews, including creationism and atheism. So I think we should start off by asking NephilimFree what his view is and how he rationalises that. So that would be good. Thanks. Neph, do you want to start off?
Oh, okay. Sure, I was muted. I had to unmute. Thank you. My position is that life has been evidenced as being a product of intelligent design and special creation. We were chatting just before you started broadcast, and someone was asking, I was trying to explain that genetic change does not equal evolution. There has to be a mechanism for evolution, and science hasn't revealed one. So someone made the example, organism can get taller if taller is beneficial, but my response to that is, well, if you continuously make an organism taller, that's never going to change its anatomy, is it? And neither is making it shorter. And adding fins to a fish is never going to give it the features of a land-dwelling creature. So the evolutionist has to believe that an unfathomable measure of time going into the past is capable somehow of doing what scientific evidence has not provided a mechanism for in real time. So we don't observe any kind of mutations building new information that defines new anatomical features in any living thing. So firstly, we're left without a mechanism, and secondly, if all you can point to are changes to color, size, shape, and pattern, then you still don't have a mechanism for evolution, because you have to believe that the changes that actually change anatomy, the new features arising, somehow happen, but all we can point to is color, size, shape, and pattern, which themselves can't change anatomy. See, so they're still stuck with believing that somewhere in the distant past is this mechanism that's happening, but they can't even point to it. So I would say, why believe that happens? Isn't that actually non-scientific? If you don't have the mechanism, why is it scientific to believe it happens?
May I explain a good example, or to explain sort of furthermore my point from before, and also to talk to that a little bit? Assume that the population of humans it's beneficially to get taller, right? But you still have short people around because there's no external pressures for why you would say that particularly short people would no longer exist, for example, right? And this is where you get evolutionary drives, which don't exist anymore as harshly to human populations because of our, better ways of life and stuff like that. We're not affected by environmental changes and things like that. If there was suddenly some massive environmental change where we were forced to, only taller people survived, all the shorter people would die. And then what would happen is let's say 100 years later, we find fossils, and it's like, oh, here's pre-humans to what we are now as 100-year later humans. Look at this. Oh, wow, they're shorter. This is bizarre, because the current population at that time, there'd be no one below, let's say that it was quite a high drive. Let's say you had to be quite tall, like 7 foot. Wow, we haven't seen anyone under 6 foot for 50 years. This is bizarre. It's like a pre-human, I suppose. I mean, I don't sort of see how. I mean, you see that happening over a short period of time. You imagine like an enormous amount of time. It's like a pre-bug thing died. Well, not bug thing, but pre sort of ape-human thing died. Thousands and thousands of years ago. It's what we are, but it died so fucking long ago. Sorry, I'm not sure if we can swear. But anyway, I don't know if that helps to sort of explain my point a bit more.
Well, I do understand, but all you're expressing is faith in deep time without a mechanism. So, for example, your example with creatures get taller and the shorter population dies off. Well, that's all well and good. That's natural selection, and can even do that. And natural selection is a real thing. Natural selection is merely the observation that creatures which are suited for their environments thrive, and ones that are not don't. But But changing height, again, I point you to the fact that changing height itself is never going to cause one type of creature to evolve into another. You have to have something more than height, because evolution theory posits that anatomy changes. And that's how fish became, over long periods of this imaginary time, became land-dwelling creatures with lungs and not gills. Legs and bones with tendons, and with cartilage with digits and not fins. See, that's what evolution theory claims. It claims anatomical change takes place at a very rapid pace. Actually, in the history of this world, according to evolutionists, if it's billions of years, it has to be actually vastly rapid. We don't even see it happening. But so changing, see, the example you give doesn't evidence anatomical change, just bigger or smaller, change in color, change in pattern, even change in shape. Look at the difference in a Chihuahua skull and that of a Great Dane. They're still 100% dog. See, there's no anatomical feature found in one dog, not in all dogs. See, but evolution says otherwise. So all you can ever point to is changes to color, size, shape, and pattern, and that's insufficient to explain the various anatomical features that exist in tremendous variety in living things. You still have to have a mechanism, and there is none.
I think we're going to just jump to someone else.
Okay. Hi, Neff. We've never spoken, and I'm a layman when it comes to biology, etc. But I did have a question, and I'm curious as to your answer, because I really have never had a definitive answer to this. I understand that you have your points of view, etc. But I'm curious. You're not a scientist, so and people don't have to be scientists to understand science, but you're very sure about certain. The question is, why wouldn't you, for example, try to write a peer-reviewed paper with some very, some evidence and studies? I really am curious as to why you wouldn't do that.
I hear atheists ask this question of creationists all the time, and I could just turn it around on them. Why don't you write a peer-reviewed journal paper and submit it that proves evolution? What is the actual point of that?
There are many peer-reviewed papers that prove evolution, but there are none that are peer-reviewed that don't. So why wouldn't you want to overturn all these findings and revolutionize science as we know it?
Well, it has all been overturned, and all the evidence that overturns it is written by the evolutionist scientists themselves. For example, when they write a paper about genetic mutation in a study, and they explain the observed effects of the mutations, they never point to anything that's evolutionary change. So all they're doing is endlessly providing evidence that their observation of the observed effects of mutation do not cause the anatomical change evolution claims has.
So you're saying that the scientists themselves are disproving evolution in peer-reviewed papers?
Absolutely.
Well, my question would be, why wouldn't other scientists be aware of this?
Well, there they are. It's just the evolutionist scientists refuse to see it. I mean, let me put it like this. When they write a paper about the effects of genetic mutation, what do they typically observe as the effects? Weaknesses, deformity, and death. That's the typical, on a rare occasion, something that's actually intelligent design evidence, that the organism is capable on the fly of creating a novel enzyme in order to break down nylon, something. That's an ingenious process. That's intelligent design. But do they ever write, this creature is gaining a new cartilage in an area where it didn't exist before. We continue to mutate its offspring, its offspring's offspring, its offspring's offspring's offspring, and the cartilage keeps on growing. No example like that in any science journal.
Right. So your point is either it's being suppressed or they just have cognitive dissonance.
Cognitive dissonance. They're unable to see the evidence for what it is because they fervently and faithfully believe that somehow it happens despite the fact that the evidence.
Oh, damn.
I hope he
comes back.
Actually.
Yeah. Yeah, he was breaking up a little bit,
sure,
and maybe his connection died or his browser crashed or something. Well, hopefully he'll come back.
Okay.
Welcome back. Welcome back. Okay, I'm pretty much done. If somebody else wants to ask, I mean, I could go on, but I know other people do want to ask a question. So.
Nicola, did you have a relevant point to this discussion? I know you've been. If not, Katzma, did you have a relevant point?
Yeah, I don't think I think Nephilim. You're not getting how it really works. It's slow, incremental changes over time that occur, and you're not just suddenly gonna get one species that pops out of another. It doesn't work that way. I think it's a species becomes a different species, no longer breed with the same species, but the change is slow and incremental, very slow.
Well, I mean, you're welcome to believe that, but see, we don't even know of a mechanism for it. Instead, what we know is this. Organisms are defined by prescriptive genetic information that defines various creatures. A llama is defined by the genome of a llama. A catfish is defined by the information in the genome of a catfish, and so on and so on. We don't see any new genetic information arising in the genomes of creatures that define new anatomical features. That's a necessity if evolution theory were true. So
there was a time where only the things that were existing could possibly exist in the environments that were there, if that makes sense. Like those particular cells developed into those particular species, if that makes sense.
Well, I know that you believe that.
That would only make sense if genetic structures copied each other exactly, in which they don't copy each other, and those are the instructions as to how to build an organism. So to say that there's no mechanism, that's not true, because genetic structures change over time, because it's like an old magnetic tape. It's a copy of the copy of the copy. Of course, there's going to be changes and mutations within how many times it's copied.
Well, you're welcome to believe that, but all you're doing is expressing your faith that it takes place. You can't cite me a single scientific example.
Well, it sounds like you're expressing your faith in the fact that it's intelligent design. You just state that it's intelligent design before. I don't see why you say that's an intelligent design.
Well, I can.
Whereas it's something that's beneficial for survival, which is optimal, obviously, for a species to maintain its survival. So, I mean, anything that's geared in that direction makes sense. In terms of,
well, I can give you a reason. I'm sorry. I thought you were finished. I'm a little too quick to respond. Please continue. I didn't mean to interrupt you. I thought you were finished.
Well, I wanted to say you can go on Google and find out thousands of information about how genetic structures work. I mean, it's all over the place. Yeah, the proof is out there. All you gotta do is look for it.
Well, I have. I've looked intensively. See, but you're still expressing faith in a mechanism which is unknown. And you asked me. Now, I was asked, what is it? Why should I believe intelligent design? What's the reason for believing that? Well, let me read to you a paragraph that I wrote. It describes one of my perfectly good reasons for believing intelligent designs.
Which is a faith.
Evolution theory was plausible for people seeking naturalism. A naturalistic explanation for life 100 years ago. Things have changed. We now have modern biological science. Now here's the reason, okay? This is a rather long paragraph. I'll try to read quickly. Life is based on information which is digitally encoded and stored in a more compressed form than man's best computer information compression schemes. It possesses thousands of three-dimensional information hierarchies directed to the cell. When a DNA molecule is super cold as chromatin, much of its information is unavailable to the cell. Much of its information is available to the cell, which is not available when the molecule is uncoiled and vice versa. Genetic information, when read by the cell's machinery in one direction, produces different information than when it's read by the cell's machinery in the opposite direction. This feature alone is far superior to man's best computer coding software technology, because it's impossible for us to write a software application in two directions and providing separate programs. Okay, its information sequences are overlapping and nested, sharing base pairs between sequences across the entire molecule. Its information sequences across a 7-foot molecule are organized to conform to linguistics laws that go beyond Zipf's law. It contains codes built upon codes which regulate the use of each other. Its information processing possesses in chemical form the human language properties of phonetics, semantics, punctuation, syntax, and grammar. Its information input and output processing includes the analytical operations of proofreading, information comparison, cut, insert, copy and paste, backup, and restore, all of which are operated by algorithms which require if and when statements, just like a computer program. Information, algorithms, linguistics are all immaterial, and nature has no potential to produce them. They are products of a mind. During an organism's development, the genetic information instructs the cell on how to turn on and off, like chemical light switches, many sequences of information in a supremely complex and not yet understood orchestral arrangement of various groupings in orders, and so as to build the structures of an organism. These patterns of genes being switched on and off are so complex, man will likely never decipher them. Science has proven that evolution well, anyway, I won't read the rest of it. But you see the point. Genetic information is the most complex thing known to exist in this world. It operates algorithmically, information copy, paste, input, rewrite, proofreading, three-dimensional hierarchies of information, all manner of this stuff. When read one direction, it provides one set of information. When read the opposite direction, it provides another set of information. Both are critical to the organism. This is technology that's superior to man's. And yet people are going to know this in the 21st century and still believe evolution is possible. I would say that's like finding a computer in a desert and proclaiming to yourself that the wind and rain could have built it over 1 million years.
Okay, so Dylan wanted you. I'll just say this quick because it's in the text step. Dylan wanted you to provide a source for that. So if you keep that in mind, and I think Nadia now wants to respond to your point. Are you okay with that, Nadia?
I can go in the microbiological direction or the philosophical direction. You want the biochem first or now?
Yeah, sure. Yeah.
Okay.
Oh, and
so,
if you could keep in mind the point that Dylan made for your next response as well. Thanks.
Sure.
Yeah. The trouble with some of these analogies with computers is that the computational models actually don't align with the chemical processes. And it's also very much an oversimplification. To the extent you're going to, say, claim some kind of advancement, you might be better served by offering a more distributed notion of where the information resides, and also a more complete account of the mechanisms, such as involving the ribosomes and other free amino acids and enzymes. So go ahead.
Is it my turn to respond? Okay. Sure, I'll give examples. Yes, it does, Nadia. Research this paper. This is from the Department of Pharmacology and Toxicology, Rutgers University. The Linguistics of DNA, Words, Sentences, Grammar, Phonetics, and Semantics. If you read that paper, they explain how the chemical processes of the DNA molecule are exactly likened to human language properties like phonetics, semantics, syntax, punctuation, and grammar. So the name of the paper is, I'll read it again for you, The Linguistics of DNA, Words, Sentences, Grammar, Phonetics, and Semantics, Department of Pharmacology and Toxicology, Rutgers University. I have a list, a selection of here. You might research Quantitative Linguistic Study of DNA Sequences, This discusses algorithmic processes in the DNA that go beyond Zipf's law of linguistics. Linguistics features of non-coding DNA sequences. You might look up palindromes in the genetic information. As for epigenetics, you can look up, well, there are things on that. Here's another. So all the things that I said in that paragraph that I read are actual features of the genetic information testified to by secular papers in the science journals. I'm not just blowing hot air. This is how secular geneticists describe DNA themselves.
Nadia, did you want to respond to that? Otherwise, we'll go with Nick. Did you want to respond to that?
I can't relay without the reference, so go ahead.
Okay, so we'll go with Dr. Quantum. Did you want to? You wanted to go into the biochem anyway.
Yeah, sure, I can go. Hello, Nev.
Hi.
Excuse me if you can't understand my English. I'm from Denmark, so maybe it's hard for you to understand me. I'm going to ask you a series of questions, and you can just we will go back and forth here if it's okay with you. First, I need you to define what do you mean by information when you talk about the genes and such.
I mean prescriptive information. For example, the information in a gene that codes for a protein prescribes how that protein is to be assembled. It gives specific information specified. It tells you, it tells the cell that these exact amino acids, not this one, not one like it, but this one, and that one, and that one, and that one will be placed in this exact order, so that when they superfold into a machine, they become a specific molecular machine. It's complex, specified information. It's not random. It's not willy-nilly in any way. It's specified. It's prescriptive, not descriptive.
Okay, I just wanted to clarify your position. You went on a long tangent before about digital codings and you also said that we haven't seen any morphological or physiological changes in bacteria. That's right. You said that right?
Anatomical change.
Yeah, anatomical. Sorry. Mm-hmm. Yes.
Right.
But actually, I don't know. Are you familiar with the Robert Linsky experiment?
Yes, he bred bacteria to 5,000 generations and discovered that the 500th was more suitable for the environment than the 5,000.
Yes, but it was divided into 12 sections. And one of the sections who is particularly interesting was the E. coli. And one of the biggest factors between how we differentiate E. coli from Salmonella is that E. coli is not able to grow under citrate conditions. But after about 30,000 or 50,000 generations, it were able to do that. And all the experiments also showed that all the bacteria had become more rounder in their shapes, and the volume had also increased in the populations. So yes, we have observed this.
Okay, so round is not an anatomical feature when it comes to a single cell.
It is.
No, to a single cell.
You know how many shapes a bacteria can take?
Okay, but round doesn't change the anatomy of the organism. It changes only its shape. Color, size, shape, and pattern are not anatomical. What you need is a new organelle or a new feature, a new vacuoles, something arise that did not exist in the anatomy of the bacteria.
But it can now grow under citric acid conditions. Now it uses it in a chemical cycle. That is a huge change to a bacteria.
Can you tell me how that evidences the bacteria is becoming something other than a bacteria?
It has changed species. It's no longer the same E. coli anymore. Because the main thing that differentiates E. coli from Salmonella is that it is not able to grow on a citrate. But as soon as that changes, what we have now is something new. We don't know how to define it. It's something completely new. When you are at this level of skill, the smallest changes can make such huge differences in a bacteria.
So all this does is relate to survivability of the bacteria. It doesn't add anything to the anatomy of the bacteria.
Yes, it also changes the shape of it.
What again is it about it that demonstrates it's becoming something other than a bacteria?
Well, it can't become anything other than a bacteria. Bacteria is a domain of life. It's not a species. It's a domain.
Okay. So it's not evolving to become something else. There's no new anatomical feature that has arisen in the bacteria in its cell. Right?
Yes, I told you it became larger and more rounder instead of an elliptical shape of some sort. It became more rounder and larger. That is physiological change.
And so it became a bacteria. It started as one and it ended as one with no anatomical difference except shape. So let's extrapolate this to your evolution theory further down the road. If you change the shape,
can I just quickly ask again?
If you change the shape of a fish any number of times, does it ever become a land-dwelling amphibian tetrapod?
But it's different when it's a bacteria. It is different.
But you haven't cited any anatomical difference.
Hang on, sorry to listen. I just wanted to ask, Nep, have you blocked Fiona because she wants to join the conversation? Nephilim, are you there?
Yeah, I was muted.
Oh, sorry.
I'll see if she's blocked. But I would ask you this: Fiona likes to make points by making tiny little statements, 1,000 of them, and it takes her about 19 minutes to make a statement. You got to force her to make a claim in a minute or two at the most, because if you don't, she'll take 18 minutes to say something she could say in 30 seconds. I could do in 30 seconds.
I'll apply the 2-minute rule for everyone.
Yeah, because the conversation will go nowhere with her here if she does this continuously.
I'll make sure that no one does that. If you want to unblock it, then she can come in as well.
Can I just say something to Nep, though, about his response about saying that Fiona takes a lot of time to explain this stuff? The thing is, molecular biology isn't a very easy subject to cover in a very short amount of time. These explanations take a long time to explain. You can't just simply demand that you have it all for you in a nutshell, and without making it too vague.
Well, let me explain why I say that. Because when evolutionists are unable to provide any example of their claims, what they do is, and I just wrote something on my blog about this. What they'll do is they'll go into an endless series of micro theories, one to supposedly support the other, all of which, when taken together, still didn't provide any evidence for evolution. And it just really becomes boring listening to an hour-long discussion of, how we observed that this creature, this cytosine, and now this molecule affects that molecule. Yes. Get to the point. See, I don't have all day to listen to somebody tell me how
to
cytosine
learn any of it.
Are seen.
Okay, so hang on. What I can do is this. If at 9 o'clock in half an hour's time we could have a short break, and then if you wanted to, you could unblock Fiona, and then I'll make sure that everyone sticks to the time limit, so that I've been doing a reasonable job up to now, so that doesn't happen. Would you be prepared to agree with that?
Perhaps. I asked Fiona if she'd debate me one-on-one. She's unwilling to, so I don't know why I should be willing to discuss and hear anything.
So either way, we'll have a short break in half an hour anyway, just to let that happen if you wanted to. Anyway, were you talking Neth or Dr. Quantum? I can't remember who was talking. Someone will finish off their point.
Yeah, I just wanted to clarify. First off, Nef, a bacteria still being a bacteria has nothing to do with speciation. Nothing. A bacteria, it is a domain of life. It is. I'm not sure. Do you know how the tree is built up? The evolutionary tree of life. Species are very down below in the bottom, and at the top we have how we go from prokarya to eukarya and akarya. You're probably familiar with that. So, of course, it is still a bacteria. Yes, it couldn't be anything else, of course. But it's no longer an E. coli bacteria. It is something completely different. And the anatomical, morphological, and physiological change is that it is now able to use citric acid in its living conditions.
That's not anatomical.
That is an anatomical difference.
No, it's not. That's biochemical. That's not anatomical. No. You need to go look up the word anatomy in the dictionary. You're so far out in space here. I don't know how do you explain to somebody that a biochemical change in an organism is not an anatomical feature. See, I don't know how to even help you.
Neff, it is a difference in it.
A difference, yes. It is not an anatomical difference.
Yes, it is.
No.
Neff, listen here. Do you know how a cell is composed, how it uses all chemicals? Do you know that? Do you even know what an action potential is in a cell? Do you even know what a sodium-potassium pump is? Do you know that?
That's not going to provide help for you.
Just answer the question. Do you know what those things are?
Do you know what a hyperfocal distance is? Is that going to help you? Is that going to help me?
No, but you are answering my question with another question. Answer my question.
Your question is moot. It's an attempt to move the goalpost.
No. What I'm trying to tell you is that when we're talking about bacteria, even how they use chemicals in order to survive, that is anatomy in a bacteria.
It's not.
Bacteria is composited of organic materials. So even when you change how it uses other organic compounds, that is an anatomical difference in it.
No, it is not.
Yes, it is.
No.
Yes, it is.
I don't know how to help you.
Okay, so we appear to have reached an impasse here. I think Nadia has a point though she wants to make.
Yes, well, the paper you gave might be from a secular source. I would actually argue that they are inappropriately trying to superimpose pre-existing abstract models of computation on the cell. There may be one that can represent the cells in terms of computation, but their notion of a Turing machine is vastly oversimplified for the various interactions in the cell. For instance, the tape is not the medium of output in a cell, where in a Turing machine, essentially it transforms the constants of the tape in the course of its computation. There are some more elaborate models than Turing machines that have a separate output stream, and they are in like fashion tapes, where in the cell you don't have that kind of working space, and also the influence of various enzymes, DNA methylation, histones and chromatin and so on are not accounted for, amongst numerous other enzymes and such that are involved. So those would all fit into a model of computation that was sufficiently elaborate to represent it, but the one they're actually trying to superimpose isn't elaborate enough. Go ahead.
I say it's highly specific. Let me help you understand something. I don't want to deal with this any more than I have to because it's so ridiculous. Let me explain something about this claim. Webster's Medical Dictionary defines anatomy as a branch of morphology that deals with the structure of organisms. Right? So structural design, the structural makeup, especially of an organism and of any of its parts. Now, you're confusing anatomy with biochemistry. Even in a bacteria, the definition of Webster's Medical Dictionary of biochemistry is chemistry that deals with the chemical compounds and processes occurring in organisms. So your citrate example is a biochemical example, not an anatomical one. Be careful to confuse things in science. You don't, I'll say this, in order to argue for your theory of evolution, you have to swap two different fields of science to make a false claim. There's a problem. So in conclusion, we don't see any anatomical change in any organism. Evolutionists believe that it happens in unimaginable periods of time in the past, even we don't have no mechanism for it. I'd say the very existence of the DNA molecule, complex information read forward and backward, producing different information, et cetera, overlapping nested sequences, codes upon codes that regulate other codes. To believe that evolution is true in light of modern science is just ridiculous. Life is so clearly designed.
Did you want to respond, Nadia? Otherwise, I note that Prudent has been trying to talk for quite a while, or did you want to respond to that? Nadia, are you there? Okay, Prudent, did
I'm
you
here.
Okay, did you respond to that?
I'm not sure how to, given that it doesn't really apply to, I guess, our dispute about models of computation being embodied in the cells.
Well, Nadia, you should go look at that paper that I provided you by Rutgers University, where they describe the chemical processes in the genomes of living things as algorithmic. You might also look at Vane Basic, a geneticist, in his work describes the algorithmic processes. He said they are likened exactly to algorithms. They are algorithms, they're just chemical ones. Just as a computer operates an algorithm by turning switches on and off, organisms operate algorithms with chemical switches. It's the same process. It's just one is chemistry, the other is microscopic electronic switches.
Yeah, I was arguing from my knowledge of computer science that the model of computation they employed was inadequate to represent what they're trying to model.
Well, I'm afraid that you're at odds with those scientists then. Do you think that they're wrong and you're right?
I read the paper and came to that conclusion when I read it.
Well, why do they state emphatically that these are processes of the cell? That it is in fact likened to linguistics. Is this the same argument that we hear from evolutionists? It looks like a car. That doesn't mean it's a car. We just use the word car to describe it. Is that the kind of argument you're trying to make? Because that's what evolutionists do,
No, I argued that in terms of model computation, you can invent quite a number of them. For instance, there are Baden-Neumann machines and linking machines and push-down automata and so on. And these, the model that they're attempting to employ in claiming that the cell is somehow like a computer or DNA is like a Turing machine's tape is not rich enough to represent the actuality of what's happening. Granted, I know less about the biochemical aspects than the computational, but go ahead.
Well, if that's not so, why do the scientists that are evolutionists themselves describe these properties in just that fashion? Because the journals are chock full of science papers about genetics that describe things in this way. Codes, they describe genetic code. Well, they use the word code because, well, it's code. They use the words linguistics, like Zipf's law, linguistics, because, well, it's linguistics.
I'm sorry to interject here, but it's horribly mistaken. I mean, I've studied programming for about a couple years, and in retrospect, DNA and genetics itself isn't comparable to programming at all. I mean,
I would say that's completely false. I'd say that's an example of how evolutionists are in denial of what has been discovered since the days of Darwin because it doesn't fit their paradigm. Evolution can't be true if the DNA molecule is an unfathomably complex software application, which is what it seems to be. And so in order to cling to evolution theory, they simply deny the discoveries of modern science.
No, they don't. It's just that you're denying that they're there.
It seems that if you don't accept your definition, you just have to be in denial about it. You just simply have to resort to, well, no, you're wrong, and you're just in denial.
No, I can support this. Let me give you an example. I've got lots of these. Okay, Michael Polanyi, former chairman of physical chemistry at the University of Manchester. He stated this. he says, as the arrangement of a printed page is extraneous to the chemistry of the printed page, so is the base sequences in the DNA extraneous to the chemical forces that work in the DNA molecule. It is this physical indeterminacy of the sequences that produces the improbability of any particular sequence and thereby enables it to have meaning, a meaning that has a mathematically determined information content. So what he's saying is the arrangement of the base pairs in the DNA is not a necessity. They can be arranged any which way. You can build codons any which way you want to. So it's not a chemical necessity for DNA to possess the information, the algorithms, the linguistics that it does, or the information. The code system itself is not a necessity of chemistry, and yet there it is. So I would say that you're at odds with Michael Polanyi and with about hundreds and hundreds of other scientists. It's just a denial of the modern discoveries of science because they don't fit the evolution paradigm.
But how in the world does that prove that God, that in fact that God, the one who's doing this?
Excuse me. Well, because a mind is necessary for information, linguistics, or algorithms. These are all products of mind. It's the only potential source for them.
How do you know that?
Because they're all by inference. All examples of these that are. Wait, let me finish. All examples of these that are known are from mind.
How do you know that mind is right or
also,
correct?
And for example, an algorithm requires an if and when statements. Comparison of information. For example,
actually, no, it's if and then.
So,
well, that's true, right? If and then. Okay, so an algorithm might say if A. I'll just dumb it down real simple, make a case. If A is bigger than B, then go do C, right? That's algorithmic, right? But
yes.
Chemistry doesn't have any if in itself. Matter simply is. It interacts with the law, with itself, with other matter in accordance to the laws of physics, if it can. There is no if I'm able to. There's no if I am, then go do. There's nothing like that in chemistry. Molecules simply are. There is no mind involved, so there's no forethinking in chemistry. There's no forethinking. There's no, if I can do this here, then read X base pairs of DNA, go down here and find this one, and start from there and read exactly this number of base pairs and stop. See, that chemistry doesn't have any forward thinking, but this is what we see in DNA. It's all throughout the genetic molecule. That requires a mind.
No, the DNA itself has a set of instructions that already tells it what to do, and yet we don't.
Instructions require a mind.
Not necessarily. I've written AI that can they're able to do a set amount of tasks in a video game or on my desktop, so it's able to open up Internet Explorer or open up Google Chrome whenever I need it to, or whenever I'm away, or whenever a task is needed for me.
Do you see?
And that doesn't need my mind. It just does it automatically.
Do you see the great flaw in your thinking on this? Where did it originate? What
Me.
created it? Right.
Me.
Right.
Yeah, but I created the set code that allows it to think for itself, so it can do its own set of tasks.
That's what DNA does. It had a designer just like your software application did.
And how did that prove God? How does God, the designer, when he had no imprint of his design? See, whenever I make code, I leave a little imprint that it is my design. It is of what I created. But God hasn't left anything like that.
He's left us his inspired word in which he states, "There is none before me, none after me. I."
No, I mean like a little imprint. You know what I mean by imprint? Like there's a little signature and everything, like in a watch.
Okay.
Like, so, in every watch designed, there's a little thing that every designer puts, so everyone knows it's theirs.
So if you take the imprint, if you take the labels off the automobile, if somebody showed you a model of an automobile built in Slovakia in 1970, you don't know who this car maker is. You never heard of this brand before. They went out of business in 72. Okay, and there's no labels, no emblem on the car that says, this is a Yolansky or something, right? Are you going to tell me that you would believe that car is potential because there's no mark on it that says who the designer was? It could possibly have been something that the wind and the dirt and the rain.
you're able to look up the designer, you're able to look up where the car originated from, and then look further into this, so then you can find out who's the manufacturer of this car. Mm-hmm. That's easy thinking.
Well, it's obviously a product of an intelligence. You admitted it. You're the intelligent agent that made it, and so is an automobile. And so is a cell. A cell is also has the imprints of intelligence. It has genetic information of astonishing ingenious design, features, properties which only come from mind, information, algorithms, linguistics, and code. Chemistry in nature has no forward thinking. Chemistry, matter does not think forward into the future about what to do if or when. It just is. But every living thing on this planet operates by information which is digitally encoded, overlapping and nested, read forward and backward to produce separate but critical information, possessing human language properties of phonetics, semantics, syntax, punctuation, and grammar, complex specified information. It's specific. It's not random garble. It's specific. It's specified. It conforms to linguistics laws. And it's overlapping and nested. You're welcome to believe that nature can do that, but now you need scientific evidence that chemistry can do these things.
And there is. I mean, it's just that the fact you just don't want to look for it or believe it because you're so enclosed in that little box of yours that you just don't want to see it.
So what is that evidence that nature can produce those things?
And I will tell you what I told everyone who keeps asking me that: look it up for yourself and not ask me. Look it up for yourself and prove to yourself that it's there. Don't ask me.
I've investigated the subject extensively, and no scientist has ever put.
Neff, I know what you do. You just read the top. You just read the title of any paper, and then make an inference on what you read. This is.
No scientist has ever put forth any evidence in any paper in any journal that nature is capable of producing information, linguistics, or algorithms.
Have you actually looked into that at all, instead of taking your own word for it?
Yeah, I've done searches, read the abstracts of many papers in science, and nobody ever likens anything that they find to no chemist. I'll give you a testimony of one scientist. His name is excuse me. Let's see if I can remember his name. Frank Turin. I'm getting his name wrong. Maybe I'll remember it. He's one of the 10 most cited scientists in the world. He's a chemist, and he became a creationist because of the evidence in creation. He is one of the 10 most cited scientists in the world. That means of all the scientists whose papers or whose work are cited by other scientists in their papers, he's one of the 10 most cited scientists on the planet. Okay, he says, I don't understand this evolution theory. I understand chemistry. I build molecules for a living. I know how difficult it is to build a molecule. He says, there is no reason, nor scientists have ever provided any reason to believe that chemistry is capable of producing the properties of the DNA molecule. Now, he's one of the 10 most cited scientists in the world. And I'm just going to have to go with what he says. You can go with what you believe exists in the journals. I'm going to go with what's really there, and that is the description of it, but no offer of an explanation as to how it could have come into being.
Okay, so Kim, I think this is a good opportunity. I'll let you finish off your point if you were going to make one, Matt. But is it possible we could have the rate now? If you want to, because Fiona really wants to join. So if it's possible, you could unblock Fiona, and then we could get her on, and I'll make sure that we stick to the 2-minute time. If you're okay with that, Neff. I think we might have to leave the hangout while you do that. Are you okay with that?
I tried to find her in Google. I'm trying to do it right now. When I searched for Fiona a few minutes ago, her channel did not pop up. I'm still trying to do it. I would refer you to this quotation that I just provided here. No physical hypothetical mechanism has ever been suggested for the generation of nucleic acid algorithms. That's from Travers and Abel, Chance, and Cell Biology International, Volume 28, 2004. So, of course, these guys read the papers, the journals themselves. There's no chemist, no biologist has ever offered an explanation as to how algorithms could exist in the DNA molecule by natural process. So when I say a thing, I can back it up. There you have it. That's in a science journal, by the way. But I'm still looking for Fiona. Let's see if I can get her.
Check out your Google Hangouts. That might be the problem. You might have blocked her in Hangouts by accident.
Nadia just posted her profile for you, so you can check her profile directly.
Okay.
Yeah. Go straight to the profile. It'll have a gray thing that says blocked underneath her name. You can click on that. It'll bring up pop-up. Gives you an unblock button. You'll have to refresh after you do it.
Yeah, the page is locked up. A script has got it locked up. It'll probably clear up if I wait a few seconds. Just have to wait for the script to stop.
That's usually something to do with the active, like, external text chats and stuff.
Okay, I'm at her.
You'll be able to see it. Go ahead.
I'm at her page, and it shows mute Fiona and block Fiona. So now this is from my personal Google page. Let me go to my YouTube page and then access Google Plus from there in my other profile, my NephilimFree profile. Maybe I'm blocked there, so I'll try.
Yeah, the different profiles have different block lists, so you'll have to be sure you're using the same profile you're using in this Hangout.
Right. So let me try it that way.
No, this is actually a pretty nice setup. I kind of like this. This is my first time actually being here. It's pretty nice.
Welcome to the party, pal.
I hope I come to future discussions. This seems fun.
Yeah, I've been for a while, actually.
Oh, really? For how long?
Well, since it started, Quantum and and I were for the first time ever on the Magic Sandwich Show together. Just happenstance. It was our first time ever on a discussion thing, and ever since then, Quantum's been doing the show, and I've been invited. So I don't show up sometimes for a few months at a time. I get busy, but I do try to show up.
It won't allow me to do it. It keeps taking me forcing me to my other profile.
Try closing your browser. Are you using Hangouts on its app or the browser itself?
In the browser.
You might have to close your browser and then try load it up again, see if that works, or just sign out of your profile.
I have to leave the Hangout to do that.
Are you
I'll make sure that the Hangout isn't filled up, so you can join back immediately.
Okay. I'll be honest with you, I'm not really too keen on the idea of talking to her because she lied about me and she did so publicly. She said that I lied about her having a PhD, that I said that she did not have one. I made no such comment. The post that I made on that video that was made by G-Man was that I questioned whether or not she was truly a Christian or whether she was a wolf in sheep's clothing. I never mentioned her PhD. But she's turned around and publicly said that I lied about that and that I questioned whether or not she had a PhD. And she argued with me of that publicly in a Hangout. And I don't appreciate people lying about what the things I say. I never mentioned her PhD.
We'll make sure that we'll keep it civilized if we do that. I mean, if the Google thing forces you to leave your Hangout, then I'll make sure that no one else joins so that you can come straight back.
Okay.
And if Fiona's still here, maybe she can bring that evidence forward or not, if that's true. That if Neff actually said that. If she is still there.
I don't know if she is, but Fiona, if you are, please try to join. And I know you were watching for a bit, so hopefully you still are.
Right. This has happened to me before. It's an absolute pain in the arse. The Google.
This is why I've never blocked anyone ever.
yeah, it's a really bad idea. Never block anyone because this is what happens.
Yeah, I've never.
Overcomplicates a lot.
Yeah, I have never to date, and I could have with some people, but I still refrained.
By and large, a lot of the difficulty comes from, well, difficulty in managing multiple accounts, as Neph was just describing here, and frankly, just plain people being dishonest about who they're blocking and not. So.
Well, she hasn't been responsive for the last 20 or so minutes, so I don't know if she's aware. But we'll see, I guess, if she comes or not. Ah, there we go, Fiona. Welcome.
Welcome, Fiona.
Hello.
Welcome.
Can I be the first to ask Nephilim the question? Because I've been waiting for now.
Okay, so
Yep.
Hi Fiona. I don't really we've met before. I'm Quantum Overlord. I host the Supernatural Sci-Fi show. Currently, we have a format where Nephilim talks of under 2 minutes, and then the person responds for under 2 minutes. So I am going to be quite strict on the timings. It's just to ensure that there aren't loads of people in the hangout at once shouting at each other. That's the only reason why I've done it. That's okay.
Is she muted?
Yeah, that's fine. That's fine. That's no problem for me at all.
Thank you very much.
And I will just say that you're asking me to bring evidence of what Nephilim had said. It was scattered through numerous comment threads on G+.
Can you if he comes back, maybe try to screen share it so you can see it or something like that?
I would be hunting back through almost a month's worth of G+ posts, but 4 other people did confirm they saw it as well.
Okay.
And they confirmed it. They actually confirmed it in a hangout with Nephi, and they said to Nephi, "I saw you do it." The 4 people said they saw him do it.
Too bad we can't bring him in the hangout.
Right. But I think that's just
right. So I think what we'll do is
done and dusted.
Let his question of under 2 minutes, then let's have Fiona responding to that. I'm just going to get rid of this bloody screen share. Okay, so Neph, if you want to start, and then Fiona will respond to you. Okay.
Well, I don't know where to go. I mean, what am I to say? Life has been proven to be a product of special creation. God's Word states so. The scientific evidence validates God's Word on the matter. Excuse me. Life is based on information that defines organisms. It's complex specified information. It's overlapping, nested, forward read one direction provides one information, read the other direction provides another. It's algorithmic. It's coded. It's a code system. It has overlapping and nested information sequences, and it's just irrational to believe in the modern era that evolution could be true in light of what we've discovered. People that say evolution is true in light of the modern era are just unable to find a mechanism for evolution. They're clinging to evolution theory because there's some reason that they want evolution to be true. It's as a gross misrepresentation of truth as it's like somebody sitting on a couch in a room with blue boxes all along the walls and saying, I don't know what the heck you're talking about. I've never seen this evidence for a blue box. What the hell are you talking about? That's how absurd it is to believe in evolution in the 21st century.
Do you want to respond, Fiona? Are you there?
Okay. Well, first of all, we point out that evolution is defined as the change in allele frequencies within a population over time. We actually observe and study the change in allele frequencies within a population over time. Thus, we observe evolution. It is seen. It is studied happening. We can actually follow the genetic changes. So to say that a belief in an observed process is irrational is irrational in and of itself. If you can see that process happening, then it is irrational to say it doesn't happen. It's closing your eyes, sticking your fingers in your ears and shouting la la la. Now, you can argue with the definition of evolution if you wish. However, that is the definition that is used by scientists. The change in allele frequencies within a population over time.
Well, I would ask, if that's what you think evolution is, can you show me an example that's scientific or reason to believe that changes to allele frequency creates new genetic information that codes for new anatomical features? Because that's precisely what evolution theory contends, that it built the Darwinian tree of life. And wait, Fiona, I know you're anxious. Without evidence for this, you have no evidence for evolution. So if evolution were true, it has produced all the anatomical features of all the types of life that live in this world. Now, if you want to believe that changes to allele frequency changes how frequently a particular variant of a gene is present in a population, that's not by itself a mechanism that codes for new information. That's changing how frequently existing information exists in a population. What you have to have for evolution to be true is information arising to code for new things that do not exist in their antecedent. Can you provide me a reason to believe changing how frequently existing information in a population exists is going to code for new things? And if you cite mutation to those changed to the alleles that exist in the population, then I would ask you to provide evidence that random genetic mutation creates new genetic information that codes for new structural designs. Can you do that?
Well, I'll point out one thing. You have completely confused evolution with the theory of evolution. As I said, evolution is defined as the change in allele frequencies within a population over time. It is a process. Now, the mechanism by which that process is brought about is described in the theory of evolution. And that is natural selection acting upon genetic variation within the population. And the genetic variation can arise in a number of different ways, but the bottom line is it is mutation. There are a number of methods by which mutation can occur. So,
can you point me to it? I'm sorry, go ahead.
So if you confuse evolution with the theory of evolution, then yes, from the definition I gave, the change in allele frequencies within a population over time, you will not find the mechanism, because it isn't a definition of the mechanism, it's a definition of the process that happens within populations. The theory of evolution defines the mechanism by which the process of evolution occurs.
Okay, so back to my question. Can you give me evidence that changing the frequency in which a gene variant exists in a population by itself is capable of generating the new information necessary to code for new anatomical features? Or can you give me evidence that random genetic or any type of genetic change, any whatsoever, any mechanism, mutation, whatever you might want it to be, translational frame shift mutation, random genetic mutation, any kind of genetic mutation is capable of doing that, so that building the new information necessary for, say, the tail of a creature to produce a stinger, like in a scorpion? What scientific evidence have you found?
Could somebody paraphrase the question for me, because it went on for so long, I have no idea what he's asking me.
I'm asking you for the mechanism. I'm asking you, so you're talking about changes to allele frequency and random mutation. I'm asking you for scientific reason to believe that changes to allele frequency and genetic mutation generate the new information necessary to code for new anatomical features which do not exist in the antecedent.
Changes to allele frequency do not create new information, and I haven't claimed that. What can create new variants of a gene? A mutation. and they can then be selected for by natural selection. Now, you can get, for example, a gene duplication. When you get a gene duplication, you then have two functioning copies. One of those copies can undergo all sorts of mutations without any detrimental effect because they're still a functioning copy.
Okay, so back to my question. Fiona, can you give me scientific evidence that random mutation and changes to allele frequency generate the information necessary to code for new anatomical features that do not exist in the antecedents, so that the Darwinian tree of life is scientifically believable? This will be the third time I've asked you this question.
But I've already pointed out to you that the change in allele frequency doesn't create any new information. Therefore, asking me for the mechanism by which it creates it is asking me a known question.
I said changes to allele frequency and mutation.
Yes, but you keep including the changes to allele frequency. They are not going to give you anything new. That's where mutation comes in.
Okay, evolutionists believe that mutations act upon genetic sequences of information, transform them into new information that codes for new frequency, new features that exist in organisms. These become prominent in the population by changes to allele frequency. Eventually, you get a transitional form. Mm-hmm. This is right. That's what you believe, right? Okay, so what's the scientific evidence of it? That's all I'm asking. Okay. Where is the evidence that mutation builds new genetic information that codes for new anatomical features, so the Darwinian tree of life is believable scientifically, not a fantasy?
Well, number one, you keep homing in on a new anatomical feature. You ask that every single time. And even if you look from fish, through the amphibians, through the reptiles, etc., you will notice that the occurrence of a brand new anatomical feature is very, very rare. Look at the body plans. You see, you're asking for a feature that has never been seen before when you say a new anatomical feature. That's what you're asking for. How can I give you an example of something that's never been seen before?
Well, new roofing bones and snout bones would be new anatomical features, Fiona. And from Pandorixis to Ichthyostega, supposedly that changed a lot. I'm asking you for the scientific evidence that mutations is capable of doing that.
Right, you're asking me for an example of a mutation, a single mutation, which can result in that. Now, the problem with that is that evolution happens over a long period of time.
Yes, that's the answer you get. See, long ago and far away. You give it enough time, and what I can't give you evidence for happens anyway. This is why evolution theory is fantasy, Fiona. See, it's not science. I'm asking you for scientific reason. Not fantasizal, not imaginary.
May I ask you that when I am answering your questions, you mute your microphone so that I can't hear you laughing at me? It's exceedingly rude.
Well, here's Fiona. You know what I think is Fiona. You know what I think is rude? I think it's rude for people who say they believe in Jesus Christ to say God didn't create anything and evolution is true, but I can't give you a mechanism for it. And then mock me for not, and then mock me for believing.
I gave you a mechanism.
You did? I asked for evidence that genetic
mutation. I gave you a mechanism.
No, you gave me a fantasy. You say that genetic mutation does it, but I'm asking you for the scientific reason to believe that. You can't give
the mechanism is natural selection acting upon genetic variation within the population. That's the mechanism.
Can you show me that it's scientific to believe that happens?
Okay, let's have a look. If we take a population of bacteria that are sensitive to an antibiotic, and that we introduce the antibiotic into that environment, and we study the population, we will find that the number of sensitive individuals within that population drops like a stone, and the number of individuals resistant to the antibiotic rises. That is a change in allele frequencies. That is a change in the frequency of the resistant form. Now that resistance is encoded in the DNA. So you can have even horizontal gene transfer in bacteria to assist you on your way. But you have an alteration of the target of the antibiotic. So the antibiotic can no longer act. It can't attack its target anymore because the target has changed. And that's passed on in bacteria from generation to generation.
So Fiona, what you're talking about is
the frequencies.
You're talking about evidence of survivability. Nobody argues that creatures can't, genetically adapt. That's evidence of intelligent design. But what I'm asking you for is something you and every other evolutionist on this planet is completely unable to give. A scientific reason to believe that new genetic information arises that codes for new anatomical features. The ability to digest vitamin, the ability to utilize vitamin C, the ability to break down nylon. These things don't affect anatomy. Do you understand that?
Yeah, exactly. And that is why you always specifically ask for an example of anatomy, because you know that we have got plenty of examples. Now, as for the ability to utilize vitamin C, in actual fact, the mutation that has occurred in the primates is a loss of the ability to utilize vitamin C. The primates split into two groups, the Strepsirrhini and Haplorhini. Now the Strepsirrhini have a functioning gene. It's the GUL O gene. They have a functioning gene. They can, within their own bodies, manufacture vitamin C. However, the Haplorhini have a broken version of the gene. Almost half the gene is missing. It lacks a promoter. It lacks exons 1 to 6 and exon 11, if I remember correctly. So there's about half of the gene missing. It is not expressed at all because of the lack of the promoter. No transcript has ever been detected from that. Although people have looked, but there is no transcript. Now, that's a whole group, the whole Haplorhini group, have lost the ability to synthesize their own vitamin C. And when you look at that mutation is shared across all of the Haplorhini.
But Fiona, what you're pointing to is you're pointing to something that's a negative. The organism has lost something. That's not going to support evolution. Secondly, it's not evidence that organisms change in their anatomy. That's what evolutionists believe. So you believe single-celled organisms became multicellular organisms, and every anatomical feature of every type of living thing on this planet was produced by chance association of molecules. That's what we call them mutations, whether programmed or not. It would, horizontal gene transfer, anything you want to, all these ideas that you have. And yet we have no scientific reason to believe that the anatomy of organisms changes so there's any mechanism for it. And I've been asking you for that. You're unable to do it. This is wait, I'm not quite finished. So this is what I meant when I said, when you ask evolutionists for actual evidence of evolution, they go into a long series of little micro theories that supposedly supports an idea, and then another one that supports that one, another one supports that one, and never can give you the actual mechanism for evolution. Because there is none. You see, there is no mechanism in nature for the production of new genetic information that codes for new anatomical features. And the list of these is extensive. You've got the stinger in the tail of a wasp. It's different from the stinger in the tail of a bee. You've got the bombardier beetle's chemical gun. You've got a tongue. That's an anatomical feature. Okay? The existence of teeth is an anatomical feature. Eyeballs are anatomical features. Hair follicles are anatomical features. The list is extensive. All of these kinds of creatures, I can't list them all for you. You got the dung beetle, you got the giraffe, you name them, right? They all have different anatomies. I mean, there are types of organisms that produce after their kind, just like the Bible says, right? But there are different anatomies. Now you, as an evolutionist, have to believe that there is some genetic mechanism that codes for new information so that a new anatomical feature can arise, just like you believe a fish gained bones, digits, cartilage, tendons, and got legs instead of fins. That's anatomical change. I'm asking you for a scientific reason to believe anatomy, new anatomical features can arise because of changes to genetics. But you can't provide one. So what you do instead is carry on about, vitamin C utilization. That doesn't have anything to do with anatomy. You'll carry on about nylonase. Doesn't have anything to do with anatomy. So you'll talk about one idea and say, oh, I see. Genetics can change. Duh. Why didn't I see it before? But I don't see your fantasy. See, there is no scientific evidence for a mechanism for evolution. What we have is genetic information that codes for the features of living things, and they produce those features in every generation thereafter. Okay, with the exception of phenotypic plasticity, which proves that the genetic information was already in the preceding population anyway. Yeah. It's not a mechanism for new information.
We've gone quite a bit over 2 minutes, so I think we have a chance to respond to a few of those points.
Oh, well, I can't even remember how many points are in there. But what we'll point out is that if you're looking for a change in anatomy, you can look at what happens when there are mutations in Hox genes. But the problem there is that doesn't fit in with what is being demanded, as in new anatomical features. So if you have changes in Hox genes which change, for example, you end up with legs growing out the head of a Drosophila, that doesn't count because a leg is not a new anatomical feature according to Nephi. So when I can give an example of how a very small change in one gene can have gross anatomical consequences, that doesn't count as far as he's concerned because it's not a new anatomical feature. But the problem with it is this. Go from fish and come all the way up to the mammals, and you will notice that when you look at gross anatomy, there are very few changes anyway. You have a head stuck on top of a neck. You've got a mouth at one end, you've got a bum at the other. You have limbs of some sort. So what new anatomical feature is he looking for? He's looking for a feature that we've never seen. He wants me to give the genetic basis for a change that is not observed. If we look at our fish, and we look at sand gobies and mud skippers and amphibians. Sand goby is a fish. It behaves like a fish. It does everything a fish does. Mud skippers, on the other hand, have got extra strength in those front fins to drag themselves over mud. And they seem to be like a halfway house between a fish and an amphibian. The strengthening of the front fins. But you see, that's not a new anatomical feature because it's still a front fin. And even if it was further along and it was almost a front limb, a front leg of an amphibian, that's still not going to count as a new anatomical feature for Nephilim because legs exist. So what he's asking for is something that is an impossibility.
Okay, Fiona, you said this evolution from fish to amphibian tetrapods you argued would require is relatively few changes. That's not true at all. It's a tremendous number of changes. New organs that don't exist. Scales disappear. You've got new cartilage, new bones, new tendons, in fact, the roofing bones and snout bones of these creatures supposedly change dramatically in number. I don't know where you get this idea. That's few changes. That's millions of changes. Okay. Now, you cite Drosophila. You point to a fly. Indeed, an eyeball, where there's supposed to be an eyeball, you get an antenna or a leg. That's not a new feature. That's in fact the placement of an existing feature coded by existing information in the wrong location of the body plan. These creatures are unable to survive outside the environment of the laboratory where they're cared for carefully. They've become unable to survive. So as evidence for your evolution, you pointed to something that's, one, is caused by man. Second, in a laboratory. Two, has made the creature unable to survive. Boy, that's really going to help evolution. And thirdly, it's not a new feature. It's the misplacement of an existing feature coded by existing information in the wrong place in the body plan. You can't get evolution by that mechanism. Instead, what you get is a creature that goes extinct instantly. Okay? That's not going to help you. And then you talk about mud skippers. They're a living fossil. That doesn't help you either. They haven't changed in many millions of years, supposedly. Like tens of thousands of creatures in the fossil record, no change. Not a bit. No change. Creatures are either extinct or they still exist. If they still exist, they're called living fossils. If they're extinct, well, they're just extinct. But so you have provided nothing. I've asked you for a genetic, you admitted that you can't see this imaginary change that takes place that codes for all these features or even a mechanism for it. I'm asking you not for an observable example. That would be, that's pushing it too much. Just a mechanism.
Okay. What I will say is that Nephilim, you began with a complete straw man. I did not argue that very few changes were required to go from fish to amphibian. I didn't say anything about how many changes were required. So for you to say that I had argued that point isn't quite true, is it? That's not the point I made. Now, it seems that you're also confusing common descent with evolution. As I told you before, evolution is the change in allele frequencies within a population over time. When you are talking about the changes that we see within the fossil record, you will find that these changes do occur over long, long periods of time. But you will also find examples where there has been very little anatomical change. That's what Nephilim calls living fossils. But the point is this: if an organism is highly adapted to its environment and there is no competition, it doesn't need to change. There is nothing to drive that change. There is no natural selection. And thus the animals remain unchanged. Look at the shark. Then there's the coelacanth. Its anatomy, although they initially thought that the coelacanth was unchanged, it turns out that there have been changes in the coelacanth, but not huge changes, because it is successful in its environment.
I think you're next meeting.
Okay, so you're unable to provide a mechanism. You did say few changes. It would represent few changes, but it would be millions. If we rewind this hangout, we'll see that you did say that represents few changes. The coelacanth disappears from the fossil record for 75 million years. It's a lobe-finned fish. It still exists. It's just a lobe-finned fish. There's not been anatomical change in coelacanth either. It's a living fossil too. But see, the evolutionist is the one who believes the long ago and far away. If we just add the time, even though we can't provide a mechanism, even though we don't have an observable example, it happens anyway, long ago and far away, once upon a time. See, that's not scientific. You can't even provide a mechanism for it. I'm sorry, evolution is just false. It's been disproven. This is the 21st century. We have modern biology today. Darwin couldn't have guessed what was going to be discovered. He was wrong.
Hey, Neff, I got a question. What evidence shows that evolution's been disproven?
The existence of the DNA molecule, genetically, digitally encoded, multi-hierarchical, three-dimensional, forward-backward reading, algorithmic information processing material in the cell that codes for the features of an organism. It's proof positive life was designed.
Fiona, you want to take this? I'm not sure if you want to go.
Is this? Are we now moving into abiogenesis, Nephi?
Apparently we are.
Yeah, so.
Oh my God.
Yeah,
well, I'm sorry, go ahead.
That would mean if we're going to discuss that, then we're leaving evolution behind and we're moving into abiogenesis.
No, I didn't posit anything about abiogenesis, but abiogenesis is the last subject any evolutionist wants to discuss. But if you want to, we'll go there.
That's because abiogenesis and evolution are separate.
Well,
they're two different things. Evolution deals with speciation, and abiogenesis begins with the origins of life itself.
Well,
and you're trying to equate those, and they're not the same at all.
Well, if that's true, why do the biologists, evolutionist ones, say that abiogenesis is the evolution of the cell from inanimate matter? If you don't believe that's true,
it's just word. It's just the word. It's just the word, man.
Yeah.
I'm sorry. It's just.
Can I just cut
Sorry.
It's getting a little bit disorganized. Matt, your microphone is a little bit loud. Anyway, I think did Fiona want to respond, and then we could continue with that discourse for a bit, and you'll get a chance to say something later if you come back.
Yeah. Evolutionary biologists don't actually say a lot about how life began. That would be those that work in abiogenesis, and they tend to be biochemists and chemists, because it's to do with what reactions are actually possible. What actual chemical reactions can occur in nature. And that is where abiogenesis hypotheses are targeted and what they're being tested. It's got nothing to do with evolution. Evolution can only occur once there is something that is replicating. Until you have something replicating, you cannot have change over time within that replicating molecule.
So evolution, abiogenesis is not the evolution of the first cell from inanimate matter, and any more than the formation of stars and galaxies is the evolution of the cosmos. Huh?
So now what we're doing is we are moving from biological evolution and the scientific definition of it to the colloquial use of the word evolution.
Okay, well, you're welcome to deny that abiogenesis is evolution all you want to, but I would just say it's also an impossibility, and that's why scientists are arguing for panspermia and all this other junk, looking for some other explanation for the living things that exist.
Have you actually read into abiogenesis at all?
No,
I wouldn't be discussing it if I had.
Okay,
then if you have read into it, you'd know that they're two different things, and abiogenesis doesn't really discuss anything about evolution. It kind of just discusses, the way life has began in the primordial Earth.
Well, then why do biologists call abiogenesis the evolution of the cell from inanimate matter?
Because it's just the use of the word. It's not the use of the theory.
Mm-hmm.
There's a difference, man. There's a difference.
Really? Okay.
There is, if you knew what you were reading and not just pulling stuff out of your
well, you know,
ass, man.
You know, the current generation of evolutionists make this fallacious argument that abiogenesis, because it's given a separate theory, is not evolution in some way because they can't answer for it. And it's their way of trying to push it out of the arena, and so they don't have to try to give an account for it. That's quite obvious. But, you know, you can't provide evidence for that either. And you need abiogenesis to have evolution. There's no mechanism for it. You know, the game is over for evolution, folks. I'm sorry. It's an excuse, a naturalistic excuse.
And yet it is still a viable, and yet it is now, evolution is now a well-substantiated fact now.
Really?
It's so destroyed, man. It is so destroyed.
If that's true, then why can't you provide a mechanism for it? See? Fiona can't do it, you can't do it.
I have provided a mechanism. The mechanism, the theory of evolution, is natural selection acting upon genetic variation within a population.
And I asked you
the mechanism for evolution.
And I asked you what evidence there is that genetic variation builds new information that codes for new anatomical features. You can't cite it.
And so you're just asking multiple questions in this, man. You just don't want to listen.
No, that's
you really don't want to listen.
That's what she would have to have as evidence for her claim that change to genetic information causes evolution.
May I just point one thing out here? May I just point one thing out here? Before we get dragged off abiogenesis, Nephilim made a couple of claims there. I would suggest to him that he goes and reads a paper by Lincoln and Joyce from 2009, and that is about the self-replication of synthetic RNA molecules. And I've given him that paper before. The two RNA molecules in a protein-free system, so there are no enzymes at all. Just the two RNA molecules, and they self-catalyze their own replication. Because remember, these RNA molecules are also known as ribozymes, as in they are ribonucleic acid, but they have catalytic activity, and they can catalyze reactions the way a proteinaceous enzyme can. So Lincoln and Joyce showed that two RNA molecules can catalyze their own replication. There's also a paper out towards the end of last year that when a pyrimidine nucleotide was mixed with ribose, so just a pyrimidine base is mixed with ribose, a ribonucleoside is able to be formed. Again, protein-free system, no enzyme. It's just a chemical reaction. So that gives you a ribose sugar with a nitrogenous base on it. And when you put them together, under the correct conditions, those nucleosides self-polymerize. In other words, they form a long chain with a sugar phosphate backbone, which is an RNA molecule. Again, protein-free system. This is just chemical reactions.
Okay. All right. Well, firstly, you've made a couple of mistakes here. First off, you speak of RNA self-replication. That doesn't take place more than up to about 10 amino acids. So, secondly...
excuse me, there are no amino acids in RNA. That's the first thing I need to say before you go any further, because there are no amino acids in RNA. Amino acids are the building blocks of proteins. RNA is not a protein. There are no amino acids in RNA. So to say that RNA can't get further than 10 amino acids is a complete mistake, because there are no amino acids in RNA.
Okay. So, but it can't produce anything that goes beyond about 10 amino acids. Okay. Now,
weren't you listening?
Wait, please. RNA by itself is a product of DNA, so let's get rid of this person that's just being rude, shall we?
I'm sorry, I'm coughing.
Oh, was it you? Oh, I'm sorry.
Yeah, I'm just coughing. I'm sorry I coughed.
Okay. Oh, I thought it was somebody being rude. I was looking at something. Okay. My mistake. Okay, so RNA is a product of DNA, so you got to have that first.
No.
And first off, it's interdependent. And secondly, you mentioned ribose. But the problem with ribose, Fiona, is, see, here you believe a biogenesis is possible. But in the absence of enzymes, there is no chemical reaction that produces the sugar ribose. Okay? In the absence of enzymes, there is no chemical reaction that produces the sugar ribose. That's the backbone of the RNA and DNA molecule. So you're talking about things that are after the fact. But we can take in the laboratory and get RNA to synthesize itself up to a certain level. And that's all. But you can't even get the RNA without the DNA and the ribosomes, and the transfer molecules. It's not going to happen. You're not going to get the DNA molecule that codes for the RNA in the first place by mere chemistry, because I'll say again, in the absence of enzymes, there is no chemical reaction that produces the sugar ribose. You got to have a cell for that, Fiona. Did you just make a scientifically false statement when you said ribose? Sounds like you did.
Excuse me, is that an attack saying that I am lying?
Did you not just say that you can get ribose?
Nephilim, you need to answer that.
You said it was in an enzyme-free environment, is what you said. Then you mentioned ribose. Okay,
yes,
you mentioned ribose.
In a test tube in a laboratory, in a test tube in a laboratory, they took some ribose and they mixed it with a pyrimidine nucleotide. I did not claim that they synthesized the ribose.
Okay.
You've not listened to anything I said.
Okay, thank you for
this is the problem. Yeah, but that's the problem, Nephilim, because you actually made an accusation of dishonesty on my part, because you hadn't listened to what I said.
I asked you if you did make a scientifically false statement, and I asked you to clarify that. And that's what you did.
It, then that is the problem. Because you have to throw that in there. You couldn't even just say, have you made a mistake? You had to throw that in there.
That's exactly what I did.
Scientifically false statement. And no, I hadn't made a scientifically false statement. The point is this. I explained to you that when Lincoln and Joyce did this experiment, they didn't have any DNA, and yet they have self-replicating RNA molecules. When the ribose and the nitrogenous bases were put together, they didn't have any DNA, and they didn't have any enzymes. But a chemical reaction occurred which attached the nitrogenous base to the sugar molecule.
Okay,
no enzymes, no DNA.
But Fiona, you're talking about things after the fact. You've already got RNA. Where does RNA come from? Doesn't it? It's coded in the DNA, right?
Not always.
It's a product of DNA, right? So you don't even get that.
Nope.
You're starting with something that's already a product of design, something that is already interdependent with the cell and the genetic material to exist. You're not talking about seeing RNA form naturally by chemical guys put stuff in a lab and without human intervention, observe it, came back next week and there's an RNA molecule. Secondly, RNA is information. You don't get that by mere chemical chemistry either. Okay, and again, the sugar ribose requires enzymes to exist. Okay, so what you're talking about is like taking an automobile and saying, look, I'm going to show you how the automobile can be changed by mechanics. But wait a minute, where'd the automobile come from? Somebody designed it and manufactured it. You're talking about things after the fact. That doesn't support abiogenesis, Fiona. Sorry.
Automobiles don't breed.
It doesn't matter. It requires the cell, it requires the DNA, it requires the ribosome.
An automobile doesn't require a cell. No, an automobile doesn't require a cell. An automobile does not require a cell.
Automobiles aren't living organisms either, so,
Does RNA require
one at once, otherwise I'm going to have to be a little bit strict with this. So it would help me if people just talk one at once, thanks.
Does RNA require DNA, Fiona?
No. No, you can actually look at RNA viruses. They use RNA as their genetic material, not DNA.
Okay, that's a creature
RNA.
that is already. That's a creature that's already designed. Can you get abiogenesis of cellular organisms? Can you get abiogenesis of cellular organisms? Can you get the RNA in cellular organisms, like any cell, even a bacteria or a multicellular organisms that have RNA in them? Can you get the RNA without the DNA?
Once you go above the viruses and you go into the prokaryotes, the genetic material is always DNA. However, that doesn't mean that RNA cannot be, in and of itself, the genetic material, because viruses can use RNA as their genetic material. There is nothing to stop it. The fact is that the way life has developed, RNA has been the preferred molecule because, so DNA has been the preferred molecule because RNA actually undergoes mutation at a much greater rate. It's less stable.
Are you trying to say that the animal kingdom came into a rise because chemistry can produce an RNA molecule in the absence of DNA?
I'm saying there's one hypothesis that is being looked at.
But you can't provide evidence that RNA can come about by sheer chemical interactions without a cell and DNA.
Well, as I say, they've got to the stage where you can mix a sugar with a nitrogenous base and end up with a ribonucleoside, and that they will self-polymerize into an RNA molecule.
So the answer is no. Outside the cell, it's not going to happen without human designing of the product?
We don't know the answer to that.
Well, wait a minute. Isn't it true that RNA depends on the existence of DNA?
No.
No,
because then you would have RNA viruses.
Okay, so
But it's not Ebola virus. Ebola is an RNA virus. Its genome is RNA. It's negative sense RNA.
Okay, so you're saying that viruses and prokaryotes are related, right? And somehow RNA in the animal kingdom developed by naturalistic processes, or you're saying it's a passover from viruses some way? Is that what you're trying to do?
No,
I asked you for a natural chemical processes that can produce RNA. Pointing to the virus is not an explanation. You're pointing to the finished product.
I gave you the example of the experiment where the sugar and the nitrogenous base underwent a chemical reaction whereby the nitrogenous base bound onto the sugar molecule.
Ribose, is that correct?
Yes.
Okay. Then let us just already point out that in the absence of enzymes, there's no chemical reaction that produces ribose.
But that's the point. I'm not talking about where the ribose came from yet, am I?
Well, that's what I'm asking you. You're the abiogenicist, not me.
But
I'm
that's
asking you
the
for
point.
scientific reason to believe it.
What I'm trying to point out to you is that they have found this reaction can occur where a nitrogenous base will bind onto the ribose sugar.
You're already starting with ribose. It was put into the vial.
Yes.
Okay.
And so was a nitrogenous base. Everything was put in a vial. But the point is this, we found out that part of it is not chemically impossible.
Wait. Is it not true that in the absence of enzymes, there's no chemical reaction that will produce ribose? True?
Now, to be honest, that I don't know because I am not a chemist.
Okay.
This is why I'm saying it's chemists that are tending to work on this.
Okay. Okay, Robert Shapiro states so in his critical analysis, Origins of Life, Evolution in the Biosphere, 1995 and 1999. That's Robert Shapiro. He states, in the absence of enzymes, There is no chemical reaction that produces the sugar ribose, which is the backbone of RNA and DNA. Now, you being the evolutionist, the biogenicist, you believe RNA came about by chance associations of molecules and nature can do it. Outside of the living cell, outside of what's already built, well, outside of the chemical interdependency between DNA and RNA. I'm not the one who believes that junk. So if you say
you've gone on about the...
You need to be able to provide a reason to believe RNA came into existence without a cell, Fiona.
You've done it again. I've shown that you don't have to have this interdependency between RNA and DNA, but you've repeated it again.
Okay, so you don't get RNA without ribose, isn't that correct?
That is correct.
Okay, there is no chemical reaction outside of the existence of enzymes, which are themselves a product of the cell, that produces ribose. So, you're starting with the product of design.
What I'm saying is that I am not a chemist. Now, there are various hypotheses about how RNA could have come about. And I will just read you this here. And this is from Bennett, Kim and Carrigan in 2012. And the hypothesis centres on a geological model that synthesises RNA in a prebiotic intermountain dry valley, not in a marine environment. And they're talking about having borate stabilised carbohydrates, formamide and ammonium formate, and as atmospheric CO2. Okay, I'll just stop there because obviously you don't really want to know about it.
Well, Fiona, you started with ribose, and
that's what I'm talking about. That's what I'm talking about.
And you're the one who believes that there is a chemical process outside of the presence of enzymes that can produce it. Because that's what to get the enzyme, you need the cell. And you've already acknowledged you need DNA to make RNA.
And what I was reading out was an answer to that.
Ribose is the backbone of RNA.
What I was reading out was an answer to that question.
Okay, has it been observed to take place in a laboratory? The answer is no, right?
Listen, this is the problem. There are so many things unknown about how life began. Okay?
Right.
We don't have all the answers, but I honestly believe that God is powerful enough to have managed to design the laws of physics so that that process could take place. You seem to think that God could not design
no, I don't
those
think God
processes.
Couldn't. I say God did not. God stated in His Word He did not. He stated He created it. He stated it. He created it, and God's not a liar. And the evidence is He did that very thing. See, I've just pointed out to you a serious problem with your abiogenesis theory. You got the RNA doesn't come into being without the DNA, and then both of them.
No. That again.
Both of them require ribose.
I have to ask you. That he is repeating something that I've already pointed out isn't actually true. He keeps going on about RNA being utterly dependent on DNA. I've already provided references where that is not the case. For him to keep repeating that.
What, the virus, right?
No, she's giving you evidence that it has under the laboratory environment, and she's giving you and the virus is one of them, and you just don't want to listen.
No. See, she's pointing to what they've done in the laboratory is take ribose, which already existed, from an organism, and put it into a vial. You're starting with the finished product. That's not going to help you. You've got to explain the existence of the ribose to explain the RNA molecule. You can't do it.
What I am pointing out is that you keep saying DNA is required when it's not.
Interject here because this is not going to end, and it does have to end at some point. So
yeah, it does have to hang out at 10 o'clock about science.
We might have time to come back to this. Some people want to make a few points. I mean, Nadia, very briefly make your point, but be really brief. so that we have time to get everything in, because I know you have to go soon, but you wanted to make a point, so make it very briefly, please.
Yes. Neff, I would, ask yourself why you feel this denial of evolution is so important to you, and particularly when it is very compatible with theistic beliefs. I mean, actually, your debate with Fiona here is she is a theistic evolutionist. So I feel that there's a lot of questions to ask about how and why you feel it's so essential, and maybe if it truly is that essential. All right.
Well, it's very important. Firstly, if you're a Christian, from the Christian point of view, you're in denial of God's word if you say that God created life through any kind of imaginary naturalistic process, because he stated quite clearly, excuse me, even Jesus Christ himself stated quite clearly it was specially made in the beginning in a literal 6-day week. So a Christian who argues for abiogenesis or evolution theory is outside of God's truth. They're calling God a liar, because his word, he has stated the opposite. Secondly, the scientific evidence supports God's word on the matter. Evolution theory is an idea of naturalism that people cling to in order to try to make an excuse for their existence without the presence of God.
Right, okay, so a few other people have got some points here. So, Dylan, you've been waiting for ages. Do you have a point to make very briefly?
Yeah, can you hear me, guys?
Yeah, you were a bit quiet.
Okay, I'll try to speak up a bit. Good morning from Australia. I'll try to keep it short. Neff, I've been listening, and you provided a lot of points trying to disprove the accepted scientific model, whereby evolution and speciation occurs naturally. And when asked for a positive point for intelligent design, you've stated that creation of code has only ever been observed when an intelligent agent has created it, referring to, for example, writing of software code. So my question, Neff, is when have we ever observed the creation of biological code by a non-biological supernatural entity, aka intelligent design?
Well, we haven't, and we haven't observed nature do any such thing either. So we're looking at the past, and we're making an inference based on the evidence, and the evidence is for creation.
Yes, thank you. That's exactly what I thought, and I agree. Yes. Given that, why should we accept your model over the naturalistic model?
Because the naturalistic model has zero evidence. All the scientific learning, the discoveries that have been made, have demonstrated the idea is fallacious. We've discovered that life is based on. I'm explaining. I've already explained in the beginning of this hangout. I stated that life is based on information and algorithmic linguistics properties. Those come only from mind. This is clear, emphatic, empirical evidence that everything that lives on this earth is a product of someone's mind. In fact, here's how it works for special creation. It's also evidence of special creation, because if you have algorithms, linguistics, and information that you want to put into a medium, so God designed these properties, the information, the algorithms, and linguistics. Now he needed a medium to do it. So God assembled the DNA molecule so that it would encode that information, those properties in it. That's special creation. That's manufacturing. So we have empirical evidence from biology that life was in fact not just intelligently designed, but also specially created. It was actually manufactured by God, not just designed in his mind, but he actually created it, made it come into being.
Okay, so George, you've been waiting for a while. I think you had a point, didn't you? Do you want to come in now?
Yeah, I had a question about 2 hours ago which hasn't been addressed. It was in the form of a question, so I'll try to make it short in a statement. There's a video circling on the... I hear an echo. There was a video circling on the internet of a medical house doctor who did research on dinosaurs denying evolution, and he had problems with transitional species. And his method of research was going to hundreds of museums with his wife, and his wife taking the photos, and that was his evidence, and he presented that going all over America within the religious groups. I had my own encounter with you, NephilimFree, about 1 or 2 years ago, and I hadn't had a chance to look up the video before the show, but it was about beaked whales. Perhaps you remember that. It was on my channel, Jungle Hyena. And basically what you tend to do is what Matt said about an hour ago. You just read the title and you go with your own interpretation. And what you do is not read all the facts, which are in an article, and sometimes you misinterpret the text of the words and you present that as evidence. It is, of course, very difficult for a person like me who is not fully knowledgeable about DNA and such things to question that. And you are you have a lot of knowledge about these subjects, but I question the validity of your research, because my impression is that you willingly interpret sometimes things wrong. And that's basically what I wanted to say.
Okay. Well, let me respond to that. You mentioned whale and evolution. I'll give you two things to think about when it comes to whale evolution. What we have in the fossil record is creatures which have anterior fins or legs, and we have whales which have neither. Okay, so whales have two bones in their anatomy called ischium, and these bones are anchors for the penis because they're anchored with cartilage and tendon to the spine of the whale. The reason for that is because whales have penises up to 12 feet long, and they weigh tons, and reproduction can be a very violent creature when you can get the drift. So God gave them these two bones as anchors for the penis. Okay, but the evolutionist claims that they're vestigial of a pelvis. But here's the problem: we just have these two bones are part of the reproductive system. There is no reason to believe that any living creature ever had its penis the corpo cavernosa of its penis mounted directly to its pelvis in the past. We don't know of any such creature. Okay, but the evolutionist has to believe that there was a creature that walked on the earth, and every time it did, it was tearing and pulling at itself internally at the base of its penis when it walked, because its cavernosa were attached directly to its pelvis. That's illogical. Okay, so secondly, we have a transitional form between whales and Basilosaurus, Ambulocetus, Rhodocetus, which have all those bones. What we should see as a transitional form is creatures losing bones, etc., and then none. See, there are no transitional forms in the fossil record. You have creatures with all those bones. You have creatures which are whales that have none of them. See, there is no transitional form there. And the last thing I would ask you to think about when it comes to whales is evolutionists believe that the nostrils of the predecessor to whales migrated. They merged into a single blowhole and migrated up the skull of the creature to the top to become a blowhole. If you don't believe that, you have to believe in the hopeful monster theory, which says that the blowhole appeared all of a sudden like that without transition. That wouldn't be tenable. Okay, so you have to believe it migrated. Now, do you believe that the air passages that go to the nose of these creatures migrated in such a way that these air passages passed right through the brain of the creature? Because that makes no sense, you see.
It doesn't matter what I think of it, you avoid the main question, and that is that you willingly misinterpret scientific research constantly. That was my main question.
Okay, hang on. We've got to continue now. Now, very briefly, Nephilim, I've got a question from a user, and then we'll go straight back to Fiona. So, Marcia1 asks, could you please ask Nephi's views on older hominids such as Heidelberg, Genesis, and Ono 2? What time frame does he give them, and how does he think they relate to us? If you answer that question, and then I want Fiona to finish off.
My turn? You asking me to go ahead and speak, or the other fellow?
A user has asked a question. Could you please give your views on older hominids, and what time frame do you give them, and how do they relate to us?
Oh, okay.
This one.
Okay. Well, I would say that hominids are extinct apes. What are called hominids are extinct apes. Or in some cases, fully human bones have been classified as a hominid, a precursor, and they've been thrown out by the scientific community themselves who have acknowledged, wait a minute, this is fully human. We can't say this is any kind of precursor. Okay, so that has happened too. But the evidence, the problem with the belief that humans are related to these is one of the most powerful evidences I can give is, firstly, if you examine the features of these creatures, they're very much chimp-like. And secondly, the evolutionist has to believe that between a common ancestor between humans and chimpanzees, if you go back in time, we're related to a hominid somewhere, right? Both of us are related. We came from the common ancestor. Now, the problem with this is that human beings have 10% less DNA than a chimpanzee. They've got 10% more DNA material in their cells than you do. Now, to believe that arose somehow over the history of the evolution of human beings and chimps from a common ancestor, you have to believe that countless random genetic mutations added genetic material to the DNA. But the problem is, we don't have any reason to believe that any large portion of the DNA molecule, such as 10% of it, is junk. It's all specified information. The junk DNA paradigm of the evolutionist has been thrown out. Even evolutionists today are acknowledging this, evolutionist scientists. So I would say that had that many random genetic mutations accrued in the genome of a chimpanzee to produce 10% more DNA, would have constituted such detrimental effects to the DNA that chimpanzees would have gone extinct long ago. And to support that, I'll give you there's a science paper says changes to I forgot the name of it. Why are we not extinct 100 times over? This is a science journal paper, and the question the geneticists are asking is, if random mutation has been accruing in the genome of human beings for hundreds of thousands of years, how come, because of the observed effects of them, why haven't we gone extinct 100 times over already? So, if that being true, then you see the problem with 10% more DNA arising in a chimpanzee than a human being. That should have made the chimpanzee go extinct 1,000 times or more over, but yet they didn't. So the inference is God designed these genomes differently, see, and we're not related to the chimpanzee at all.
No, I want to.
I'll just say that takes us right back to what I was saying about the haplorhini and their inability to synthesize vitamin C with a deletion of a large part of the gene, and the fact that this subgroup of primates all have exactly the same mutation.
That's not evidence we're related to them, though.
No, you do not consider it to be evidence that we are related to them.
How can their inability to
I need to go, people. I've got something starting in 2 minutes' time.
Thank you for coming, Fiona. I really appreciate it.
No problem at all. Take care.
Take care of yourself.
Ta-ta.
Well, to that I would respond, human beings and chimpanzees might share genes, but so does a California purple sea urchin and the human being. 7,000 in fact. And we're not anatomically like them at all. Only what are called endogenous retroviruses, over 90% of them found in chimpanzees and human beings are not in the same location in the genome. So here we see that Fiona is merely making an assumption of relatedness because both of us have a particular mutation. That's not evidence of relatedness. That's just both of us have experienced a similar mutation. Lots of creatures experience mutations all throughout their genomes. Endogenous retroviruses, over 94, I think it is, % of the ERVs that are in the human genome and the chimpanzee genome are not in the same location. Had evolution been true, they should almost all, the vast majority of them. If we're such closely related historically, they should be, the majority of them, in the same location, but they're not. So genetic similarity is not evidence of evolution. Well, it's 4 o'clock, and I've got some things I've got to do as well, so I need to get going before my day off from work is wasted completely. I'm not saying it's been a waste. I've enjoyed being here. Thank you for inviting me. But I do have some things I have to do while I still have some daylight, so I need to get going myself.
Thank you for coming on there. I'm glad that they responded to all those people asking you questions. I hope this has been a reasonable experience. And the YouTube video will be up so people can do with it what they like. Feel free to come to any additional shows that we do.
Great.
After you leave, we might just have a few people just commenting on the discussion if you're okay with that. I mean, it's not as what people say, so we're not going to be talking behind your back or anything. But thank you very much for coming on. And Fiona,
I appreciate you inviting me. Thanks, and God bless you guys. Take care.
All right, it looks like we're live. So thanks, guys, for coming on and being willing to have a conversation. This will be talking about, what is it? Universal common descent versus independent ancestry of lineages. So standing for truth, always with the haplogroups and the lineages line. And Aaron,
not Aaron.
Aaron is Aaron Ra. Keep confusing that because I learned that.
Aaron Ra, is that you?
Yeah. Yes, this is Aaron Ra. Yeah.
Ain't nobody warned me about this.
So, would you mind telling us a little bit about yourselves before we get started? Aaron, go ahead.
All right, I'll go.
Do it again. Damn it. Aaron.
Let's see. So, my name's Aaron. I'm from Texas. I have a background in biology. I'll call it a bachelor's degree, if you want to call that a background. I'm not like a scientist or anything. I worked for a little while in infectious disease, laboratory science, but went on to different things after that. So definitely not an expert by any means or any stretch of the imagination. I used to identify as a Christian kind of growing up, but I was kind of a type of person who never really actually believed it really, just always full of doubt and skepticism. But as far as my position goes, like, I don't have to be an atheist. Like, I don't like desire to be an atheist. If the claims that like Standing's gonna make are true and make sense, I'm fine accepting those. Like, I have no real stake in this. It doesn't matter to me. I could really go either way. I'm just not persuaded for the theology side of the argument. So anyways, a little bit about me. Go ahead, Standing.
Awesome. Thanks so much for doing this discussion, Aaron, and thanks so much, Tom, for setting it up. I'm looking forward to it. It should be fun. I'm a Christian. I run a channel, Standing for Truth, where we do discussions, debates, videos, mainly on the creation versus evolution controversy. Tom and I have had a couple back and forth discussions, which I both enjoyed very much. So, like I said, thanks for inviting me on, Tom. I really appreciate it. My position on universal common ancestry, I'm certainly open-minded, and I am interested in looking at, I would say, the very best evidence that universal common ancestry would have to offer. And I believe that the very best lines of evidence come in the realm of genetics, because I believe it's in our DNA where the creation versus evolution debate or controversy or whatever you want to call it is actually won. I mean, many people, they don't even realize that the term genetics wasn't even around during the time of Darwin, right? Genes, traits, genetics, that's what's inherited, sperm and egg. Sperm and egg, for example, as you know, they don't pass on a fossil or a bone. They don't pass on geography or a rock. They pass on genetics and traits. So if we want to find out, say, the history of humanity, when it comes to limited ancestry versus universal common ancestry, or whether or not Adam and Eve existed, whether or not there's scientific evidence for an Adam and Eve, I think it's in the realm of genetics, where we have to look to see which version or which position is true. So I think going into the discussion, I would probably just ask Aaron to be open-minded and for him to answer the question, if Adam and Eve were true, hypothetically, what should we expect? Actually, I should say or ask, what would you expect, Aaron?
I would expect for us not to see any traces of ancestry with us and the great apes, for example, and more closely like chimpanzees, and not to see a a branching pattern in phylogeny for all other life on Earth. I would expect to see just straight lines of independent ancestry when we look at our genome, just going back to each separate, I guess you would call it created kinds or something. So I wouldn't expect to see any trace of like the history of certain types of genetic events within the genome, types of structural variants or variants in nucleotide sequences that all paint the same picture that we see from other multiple areas in different disciplines. It's a cumulative case for me that kind of adds up, that shows common ancestry. Like we don't have to build a time machine to go back in time to actually witness it. So it's more of a cumulative thing for me, and I don't think we would see what we see if the story was literally true of just kind of two people just kind of supernaturally poofed into existence at a certain period of time.
Right. So I appreciate your response there. And I do agree with what the things you were saying when it comes to phylogeny, when it comes to the relative hierarchies that we see, right? We can look at morphology, we can look at anatomy, physiology, we can look on a DNA level, on a molecular level, we can see nested hierarchies there, whether it's in the mitochondrial DNA or in the nuclear DNA. I would simply respond to those lines of evidence as relative hierarchies, nested hierarchies, I guess, in general, or more so characteristics of design. But I do agree that similarities, hierarchies, phylogeny, they are, those lines of evidence are more so agnostic to the debate, because I think it comes down to lines of evidence that can differentiate between the models, limited ancestry versus common ancestry. So I think the question is, if Adam and Eve were true, what should we expect, right, Aaron? So, we would expect one female ancestor of all people on the planet. I think you'd agree with that. And then we would expect evidence for one male ancestor of all people on the planet. But I want you to comment on the genetic data that I believe confirms those expectations. For example, in Genesis, a direct prediction or retrodiction would be one male and one female. Now, this doesn't have to be true if evolution is true, but for our model, I will admit that has to be true. And I believe that the genetic evidence in our Y chromosome and in our mitochondrial DNA point us directly back to one female ancestor and one male ancestor. And not to go on for too long here, I would just point to the Y chromosome, Aaron, and then have you comment on that. We know that the Y chromosome is passed on unbroken from father to son. And then every once in a while, as you know, a mistake happens, right? Every time this happens, though, a new branch in the family tree is formed. As you were explaining earlier, these branches that we can see. But if we look at all the branches in the world, Aaron, they go back to a single person, right? Not a chimpanzee, but to a man who lived just a few thousand years ago. That would be, even the evolutionists would refer to that as Y chromosomal Adam. And that's because every male Y chromosome on the planet is nearly identical. And then the chimpanzee Y chromosome to the human Y chromosome is only 70% similar. So how would you explain that genetic data? And secondly, why wouldn't that be, say, convincing evidence for you that maybe there is evidence for a literal Adam and Eve? Go ahead, take as much time as you need.
Okay, thanks. It's not convincing evidence for me, because that's the same thing we would expect under evolutionary theory anyways. It just logically makes sense that we would have to end up going back to an aboriginal source for the Y chromosome and an aboriginal source for the mitochondrial DNA, just based on population genetics, based on ancestry. You've got two parents, they each had two parents. It's going to exponentially grows, and if you go back just 40 generations, that's something like, I don't even know how many billions ancestors, which obviously didn't exist at one time. So you have to have the kind of this tree going back and then kind of closing back in on itself, to where you ultimately end up at some sort of point with Aboriginal mitochondrial DNA and Aboriginal Y. For what I've, like I said, no expert in this. I sell cars for a living, so I don't have much time to really research any of this stuff. And a lot of this stuff is just gonna be stuff I just kind of remember from reading throughout, out the years and stuff. So I believe the mitochondrial evidence shows that the mitochondrial Eve dates back to about, I think around 120,000 years or so. And as far as the Y chromosome Adam, I believe it's around 70,000 years. So I just don't see any issues there. They both models, a creationist model versus a evolutionary model, we would expect the same thing. As far as the differences in the Y chromosome of the human and the chimp, you said it's what, like 70%?
Right.
Similar?
They discovered that the thing is, the Y chromosome doesn't experience recombination because it doesn't have a counterpart to exchange its genetic information with. So when they initially sequenced the Y chromosome on the chimpanzee, they figured that the Y chromosome should be the most stable of chromosomes because of this lack of recombination. But they were shocked to find out that the chimp Y chromosome is 70% dissimilar to the human Y chromosome, which, as you know, all human Y chromosomes are incredibly similar. I do want to say one thing, and then obviously you can have plenty of time to comment on that. When it comes to Y chromosome Adam and mitochondrial Eve being a part of, say, a population of whether or not it's 2,000 or 10,000, as far as I know, there's no actual evidence for that. That's just hypothetical, theoretical, because all human beings on the planet are incredibly similar, telling us that we have low genetic diversity. You might be familiar with the out of Africa scenario, where there was an extended near extinction event, which reduced homogeneity. And out of that, say, population of 2,000 or 10,000, I'm not sure, whatever you hold to, you can answer that, Y chromosome Adam and mitochondrial Eve came about. But is there really any evidence that there was a population? And lastly, if you do hold to that view, based on what we know about inbreeding and prolonged bottlenecks, how would a scenario such as that even be remotely feasible, right? Because that would involve severe genetic damage, right? So these Homo sapiens would be extremely genetically compromised, and then we're to believe that they suddenly spread out over the entire planet, seizing dominion over the earth, whether or not they assimilated with, the Neanderthals, the Denisovans, the hobbits, for example, Heidelbergensis. But, that's how the story goes. But do you believe that's feasible? And then why do you believe that's feasible? But I guess before you get to those questions, how do you answer the Y chromosome dissimilarity between humans and chimps? Take as much time as you need, Aaron.
All right, thanks. Apologize in advance. I'm severe ADD, and about this time of night, my meds wear off. So give me a second to gather the shotgun blast you gave me there. So as far as the differences in the Y chromosome, it's interesting that the Y chromosome in humans and gorillas are actually similar. So there's more similarity between humans and gorillas in the Y chromosome than there is between chimpanzees and gorillas. And from what I can recall reading is just the Y chromosome has underwent over time lots of deletions and then some adding, some transpositions from other chromosomes back onto the Y chromosome. Right. And there is some crossing over that does occur. Recombination does occur like on the tips, but it's very minimal. So there is actually some recombination that occurs. So the fact that our Y chromosome is more similar to a gorilla and the chimpanzees is actually the one that's different. I don't think presents much of a problem there. There's lots to learn about the Y chromosome still.
Actually, real quick before you continue, just so I can clarify, have they sequenced the Y chromosome of the gorilla?
Yeah, actually earlier today I went on to the global database Ensemble, so I could actually pull up the different chromosomes of different types of species, and yeah, you can actually do look at the synteny between the two, or whichever one you want to look at, and so you can do a direct comparison between these chromosomes of different types of species. So it's pretty cool.
Like, okay, so synteny would be like similarity in the gene order of the chromosome. So what was it? Similarity in the gene order, or was it like base pair to base pair on the Y chromosome? Like, was it the same type of sequencing that they've done with the chimpanzee Y chromosome that they've done with the gorilla to human?
Yeah, right. And so it's the amount of information that's on the Y chromosome.
Right.
There's more like degeneration in the Y for humans and gorillas versus the chimp for some reason.
How similar was the gorilla to the human Y chromosome?
I don't know. I didn't focus on that one very much. I just remember kind of coming across it. You can always pull it up.
Like, was it in and around 70% like the chimp and human? Like, was it maybe 75%? Or because as we know, every single male human Y chromosome is 99% similar, even more, right? 99.9%. That's why we know we can trace the Y chromosome back to one male Y chromosomal ancestor. That combined with the mitochondrial DNA and how similar worldwide mitochondrial DNA is compared with, in contrast, in correlation with the low genetic diversity, that's how we can conclude, okay, we came from just two people, right? Because that's why the evolutionists had to invent the hypothetical population bottleneck of, say, 10,000. I mean, do you hold to more of a 2,000 population bottleneck, or was it 10? Like, I've heard different theoretical numbers.
I don't know. I have to kind of go by what the consensus is. I've heard Francis Collins, or I read that he wrote, he thought it was about 10,000 based on the genetic data he's looked at and gathered. So him being the head of the Human Genome Project, director of the National Institutes of Health, world leading geneticist and physician, I would tend to trust his opinion on the matters since I'm not an expert in it. So I believe he said around 10,000. And just from other information I gather, I don't really see a problem with the low level of diversity in the human population, because we see the same thing on island populations. There's no difference. So those would go through bottlenecks, of course, speciation events on islands, and they show the same variation as we do species here on the mainland. There was a paper published pretty recently that came out. You're probably familiar with it, that showed all current, about 90% of current species kind of came into being, if you want to call it that, around 200,000 years ago.
Correct.
So based on the ones that they had studied, and they all show very similar, the same percentage of variation within groups.
I guess, and yes, I do want to probably go possibly in depth into that paper, which is good. But before we go on, I guess, that rabbit trail, when it comes to the low genetic diversity, the population bottleneck, Y chromosome atom, mitochondrially, for example, as you know, if evolution and deep time is true, over deep time, millions and millions of years, I should say, any large population like that would most certainly accumulate massive numbers of mutations. And then that would result in, of course, basic genetics would tell us enormous amounts of genetic diversity. So as I was saying earlier, that's a pretty serious problem for evolutionary theory, because what we now know about mankind is that we have, as a human species, very limited genetic variation, right? So then the evolutionists came up with the evolutionary out of Africa bottleneck theory, right? So for us, obviously, if we came from just two people, that means limited diversity is easy to explain. It's exactly what we would expect. But when it comes to the evolutionary model, that near extinction event, I would agree, yes, it's going to reduce homogeneity. So that is a feasible way to explain the low genetic diversity. But the problem is, Aaron, is that it would cause permanent and severe genetic damage, right? That just means, because these enormous numbers of deleterious mutations that are accumulating due to the inbreeding, they would then go to fixation. So my question is pretty simple. I'll say it like this, or I'll ask it like this. How could such a tiny, nearly extinct, of course they'd be genetically compromised due to the inbreeding, how could that population of, say, 10,000, like you said, we can hold to Francis Collins' view on that, how could they suddenly explode in all parts of the planet and seize dominion over the entire world, being so genetically compromised? Aaron, take your time.
I think you kind of got the order of things kind of backwards. Like we didn't come up with the out of Africa theory or like a bottleneck from the like Toba eruption or something because to explain the genetic diversity among humans. I mean, that stuff was already established years ago through paleontology, fossil record, and tracing routes out of Africa that way, and also tracing the history of languages, language development. And you can make phylogenetic, if you are, similar trees just based on language that align with the trees made from the fossil record, which later come to align with the trees that we can make from the genetic record. So the chances of all of those lineages lining up perfectly seems like pretty good evidence to me that our current understanding is correct. And you asked about.
Well, real quick before, because I want to clarify. Are you saying that they came up with the out of Africa, the hypothetical population bottleneck after they discovered that as a human population we have limited genetic diversity? Is that your position?
No, we've known about that before we were able to sequence the genome. So the genetic data came later, and the genetic data just confirms what we already hypothesized and already knew from the evidence.
Well, from my understanding, because I believe it was Dr. Cy Gart, and I'd have to just double check, the evidence for the population bottleneck comes from genetics, because mankind in general has such significant low genetic diversity, right? In mitochondrial DNA as well, and Y chromosome. So therefore, to explain such limited homogeneity, they concocted the story of the out of Africa population bottleneck, because there's actually multiple theories, right? There's the multi-regional theory, but there's the out of Africa theory. So
it's not concocted. Like, we look at evidence and we see what that evidence seems to tell us.
Right.
And then we try and kind of deduce, hypothetical deductive models to kind of deduce what could have caused the, things we're seeing. And then if we find, and we can make predictions, like maybe there was some sort of catastrophic event that occurred around this same time period that matches the rates of mutations that we see that cause a bottleneck. And then if we find something like that, like this volcanic eruption, then that will help support our hypothesis even more. So it's kind of like with the chromosome number 2, we predicted that in advance, and then now it's not disputed at all anymore that chromosome number 2 was the result of the head-to-head fusion of two chromosomes that remain separate in the great apes.
Apologize, just a clarification. What did you say Sygart was talking about?
Sygart was during my debate with Erica. We were going over this same problem, and I asked Erica, how they came up with this population bottleneck, and I believe it was Sygart in the comment section who was stating that it's in our genetics where they come up with the population bottleneck of 10,000, some say 2,000, because that's the only feasible way they're going to be able to explain the limited homogeneity that we have as a human species. Because as I explained earlier, if evolution is true, well, we should have enormous amounts of genetic diversity, because these large populations would be accumulating enormous numbers of mutations. And even if I conceded that maybe there was some type of near extinction event based on this volcanic eruption, I do want to go on record saying that there are a lot of scientists and experts in the field that agree that there are some inconsistencies with that volcanic eruption leading to the near extinction event. I would just have to probably provide those sources after. But even if I conceded that, I'm still looking for an answer as to how that hypothetical population could have exploded in all parts of the world, because based on the inbreeding, based on the extended bottleneck the extended nature of it. It wasn't just 1 generation or 2 generations or even 10 generations. How did they seize dominion over the entire planet? They would have been so genetically compromised that this just is not feasible, other than storytelling.
So I'd ask, why would they be genetically compromised? What do you mean by that?
So the reason why they would be genetically compromised is because that population bottleneck would include enormous numbers of deleterious mutations going to fixation, because, as you know, inbreeding exposes the hidden reservoir of genetic mistakes. So if there's an extended near extinction event for, say, hundreds of generations or just many generations in general, the resulting inbreeding would cause permanent and severe genetic damage. And yet we're supposed to believe that 70,000 years ago, this genetically compromised population of Homo sapiens suddenly exploded into all parts of the world, thus seizing dominion over the world. I mean, it's not feasible. I mean, we would need some type of explanation for how that could be possible.
Well, I don't understand where you're getting this information from. Like, why would the genome just build up one by one different, like, single nucleotide changes or whatever the mutation may be, and then just continuously get worse and worse until those things get fixed? I'm not really following your logic there.
Are you disagreeing with the fact that evolutionary bottleneck hypothesis does involve an extended and lengthy near extinction event, and thus resulting in severe inbreeding and genetic damage? I mean, that's just the nature of bottlenecks and inbreeding. Look at the cheetahs today. I just looked it up the other day, and the cheetahs are now down to like 7,000. Because they are inbreeding, they have experienced a genetic bottleneck as well. Their sperm is degenerate. Many recessive mutations are coming to the forefront. I mean, conservationists are looking at them and they're seriously concerned that this population of cheetahs are going to go extinct. I mean, it's a very serious problem. But I don't see these cheetahs being in such a compromised state, suddenly exploding into all parts of the world, seizing dominion over the world. But that's what you're trying to say happened 70,000 years ago with this hypothetical population of 10,000 Homo sapiens. So if we see today that this leads to severe genetic damage, how is this remotely feasible, other than, ad hoc, post hoc storytelling, of course?
I don't think it requires storytelling. I mean, it requires a little more understanding of, like, molecular biology and genetics, kind of how that stuff works. Like, cheetahs, I think we can kind of set them aside because different animal, different types of environment, different types of environmental pressures than humans would have. So a separate topic, interesting topic, but a separate one. As far as the buildup of deleterious mutations, you know what cryptic variation is?
I believe so. Can you explain it?
So, and this is experimentally determined. So you, within genomes, of course, mutations occur.
Right.
And say, for example, you have a polymerase that's coming along, and it's reading a sequence of DNA, and it's going to produce a messenger RNA, and then it has to stop at a stop codon,
right,
to produce a certain protein, right? Well, there's lots of instances where you have read through, and it just keeps on going, and past that stop codon, there's lots of cryptic variation that is not exposed to natural selection. It's just mutations that accumulate over time. And lots of different variation, lots of traits are expressed from multiple genes as well. So you can have lots of cryptic variation build up, and it's kind of stored as like a genetic capacitance, kind of like electric capacitor stores energy, just waiting for the floodgates to open, and
right,
then be exposed all at once to selective forces, in which can wipe out entire stretches of structural variants that would be lethal, for example. So there's lots of ways for you not to get just some like linear buildup. It's all bad, and then it's going to end up in some homogenized state where the species goes extinct.
Well, I understand what you're saying there. I think that more so has to do with long-term genetic degeneration, like, for example, genetic entropy, which we can get into, right? We accumulate 100 new mutations per person per generation. I understand that, we could argue all day as to how many of those are completely neutral, how many of those are beneficial. But when it comes to the population bottleneck story, we're just simply talking about the result of inbreeding, right? Because I always say that inbreeding, it's like a sneak preview of where we are going genetically as a species. I mean, that's why the reduced life expectancy of, say, inbred children, well, that's reflecting the overall aging of the genome, because what's happening is the hidden reservoir of genetic mistakes, they're being revealed, the ones that have been accumulating over time. So this small population of, say, 10,000, some believe 2,000, and I definitely don't want to beat a dead horse. We can probably agree to disagree and maybe move on to human chromosome 2 after this, but I've never personally received a good answer as to how a genetically compromised population such as that, which I believe correlates perfectly with the highly degenerate population of cheetahs we see today, could have actually exploded into all the world and then seized dominion over the planet, right? I mean, some say they assimilated with the Neanderthals and Denisovans and the other so-called human species. Others say that they killed them off, right? Like I said, there's different theories, multi-regional, out of Africa. So I just see stories coming from the evolutionists, and I think we might just have to agree to disagree on that. I did hear you say chromosome 2 fusion. We can talk about that, but if you want to make a couple comments on what I just said, go ahead. Take your time, man.
Yeah, so I don't think like 10,000, a population of 10,000 individuals would be a super dramatic decrease in potential variation to be exploited by natural selection as we kind of move to different areas. Like I said, you got these different structural variants that are hidden, cryptic variation, and as we know, it takes very little genetic diversity produces huge ranges of phenotypic diversity. And the phenotype is not relegated to just the actual morphology of the animal. The phenotype also includes on the molecular level, like proteins, for example. Lots of molecular processes are going on behind the scenes that you're not aware of. We can test for, and we can see that natural selection is happening within our own bodies, within our cells, and it's selecting for various types of proteins, different structural groups attached to these certain proteins that could, in the right situation, produce a huge benefit. And there's actually really a good paper written on prions from that they were looking into. I wish I had the paper. I can link it later, but it's on yeast, right? And it shows that through a process called congruence, that these mutations, which you say are all deleterious, like nearly neutral, they're actually pre-adapted. So they're not on the negative side of zero, of neutral. They're pre-adapted to be more positive, more beneficial, based on congruence. I can get you more information on that. So if you have like a pre-adapted variants that build up as cryptic variation within the genome, and then you have environmental changes that occur, there's another process called assimilation, which is induced. We've done it on fruit flies, where you expose them to heat shock, and it pulls out these cryptic variants, and then you don't have to use the heat shock anymore. They just keep reproducing this new mutant variant based on this principle of assimilation. I mean, there's lots of good data from molecular biology on how you wouldn't have some buildup of negative mutations. It's much more complex, much more dynamic than I think you're aware of.
Right. So I'll just have to say, I don't think you sufficiently answered the question regarding the hypothetical, population bottleneck of 10,000. I mean, there's just no feasible way that such a genetically compromised population due to inbreeding. Because I think you're more so addressing long-term degeneration, right? And we can shift to that, because one thing you did say that I did take note of is that selection happens and on the phenotype, right? Because selection, would you agree selection happens on the level of the whole organism, right? Like, does selection act on phenotype or genotype?
It acts on phenotype, but you need to adjust what your definition of phenotype is. It's not just the morphology of the creature that we're describing, or of the life form that we're describing. It's also deeper than that. So on the molecular level, it's the proteins. The proteins are also that
Right.
they get expressed.
I
Are
agree.
also part of that phenotype.
But one single point mutation on, say, a single nucleotide, if it's not harmful enough for selection to see, then selection is not going to act on it, is my point, right? It has to be phenotype ultimately that selection acts upon. That's why my position is that selection acts on the best beneficial mutations, right? We can talk all day about beneficial mutations that say add new novel information to the genome, for example, or we can talk about the worst detrimental mutations, because then natural selection, of course, they can rid the population of the most deleterious of mutations. But my position is that selection cannot stop the loss of information that's actually immeasurably small due to the low impact mutation accumulation, because as you said, that's actually happening on the molecular level, right? So even if, let's say, even if only 10 of those 100 new mutations per person per generation were deleterious and the other 90 were completely neutral, that alone is still too much for long-term genetic advancement. I mean, there's got to be a type of selection that can select away such low impact mutation. And I understand there's redundancy in the genome, and I understand the things that you're saying. There are mechanisms, right? Synergistic epistasis, the cryptic variants that you're talking about. But ultimately, there's still a percentage of those 100 new mutations that are deleterious. So what type of selection is going to rid the population of those ones, I guess, would be my question, Aaron. Take as much time as you need.
Just to clarify, so Standing, your objection is that if there was a population bottleneck of 10,000, then that would create too much similarity in the genome to be able to repopulate the Earth. Is that your argument?
Right. It would be like the cheetahs that we see today. They're so genetically compromised due to the inbreeding. They're so genetically similar. There's too many recessive mutations that have come to the forefront, and that's exactly what would have happened in the population bottleneck. I believe they say it's about 70,000 years ago. There'd be prolonged inbreeding, and so in that specific case, it's the inbreeding that's the problem, and we can see a reflection of that in the cheetahs today. I mean, they were at 10,000 at one point. I just looked it up the other day. They're now down to 7,000. You know, like, conservationists are extremely worried about the
What was the lowest? What was the lowest the population of cheetahs ever got?
Right now, I believe, is the lowest. It's at
no, I mean
at 7,000.
At the bottleneck that accounts for the homogeneity they have today, like, what was the number of individuals?
Right. Good question. Good question. I believe that it's similar to the population bottleneck of humans, right? There's some that say 2,000, 10,000. I've heard some papers that describe them as 30,000, because all they're doing is they're looking at the genetic data. They're looking at the limited genetic homogeneity, and they are
what's the
coming up
genome size compared to the human genome size?
So we have 3 billion letters. Obviously, mom passes on 3 billion, dad passes on 3 billion, so 6 billion letters. Are you asking how many DNA letters are in the cheetah?
How many genes that are expressed in cheetahs versus, I think humans have around 21 to 25,000 genes.
Right.
What's the number in cheetahs?
Right, non-coding versus protein coding. I'm not sure how many are in cheetahs. Do you know?
I don't know, but I think that would be...
I got a question for you. So, as far as I know, cheetahs don't intermingle much. They have very close-knit packs, and which is why their genetic deterioration is so much greater, even though they still have a population which would potentially be able to support genetic growth.
Yeah, it's like inbreeding within inbreeding. So
right. So the problem is that like in little subgroups, and they're not really diversified in the 7,000 that do exist, which is the problem.
Well, and that's an interesting point too, Tom, because a lot of papers that I have read too is that there would have been subgroups very similar to the cheetah subgroups that we see today in that hypothetical population of 10,000 Homo sapiens 70,000 years ago. It's a very, very similar population bottleneck to what we see in the cheetahs. And I'm not saying that they would have went extinct right away, but we're not going to be seeing these 7,000 cheetahs that are incredibly genetically compromised suddenly seize dominion over the entire planet, like supposedly the 10,000 Homo sapiens 70,000 years ago did. I mean, we can agree to disagree on that point and maybe move on, because I like to touch on everything that's talked about. You did talk about chromosome 2 fusion. I find that a very interesting topic as well. But that's just my position on the population bottleneck. I believe that any explanation or every explanation I've heard is nothing more than, post hoc, ad hoc storytelling. And I understand you disagree with that. But the data is in support of a small population. For example, Adam and Eve, that's what the Y chromosome data tells us. That's what the mitochondrial DNA tells us. And that's just what our genetic diversity tells us in general. And the evolution is my position.
The Y chromosome and the mitochondrial DNA don't tell us anything about a small population. And
well, yeah, because the mitochondrial DNA is incredibly similar worldwide. That's why we can take the mitochondrial DNA and look at observed mutation rates, right? Pedigree-based studies. And that takes us back to a mitochondrial Eve just about 6,000 years ago. And that also goes with the Y chromosome.
Where do you get the 6,000 years from mitochondrial sequencing? Where do you get that from?
Actually, very good question. So we just came out with a video today. There's a gentleman named Mad who I work with on my channel. So we provided a video on mitochondrial Eve with all the papers. So there was an original paper, I believe it was 1996 or 1997, that based on pedigree-based studies, observed mutation rates. They didn't consider like evolutionary assumptions in it, right? Divergence calculations. They just took observed mutation rates, and the calculations that they got back was 6,500 years ago. But there have been adjustments now, because obviously that doesn't fit with the evolutionary story.
Hold on a sec. Sorry. So that was the coalescent time.
Right. But
6,000 years.
Yes, correct. 6,500 years.
Okay. So you do realize that there's a different coalescent time for mitochondrial DNA versus nuclear DNA, right?
Right. Very good. Well, I should ask
if you have a coalescence of 6,000 years for mitochondrial DNA, since it's just a single DNA, single genome, versus the crossing over that occurs between diploid organisms, it would be 4 times shorter than the nuclear genome. So if you're going to say that there was a 6,000 year coalescence for mitochondrial genome, that means the human species is at least 24,000 years old, which would discredit your position.
Right. Very, very good point. So would you agree that the coalescence time, at least before I go into the nuclear DNA explanation, you do agree based on these papers that there is a 6,500 year coalescence time for mitochondrial DNA based on observed mutation rates in the mitochondria? Would you agree with that part?
No, that's not in any of the established literature published in any reputable, relevant journals. It's in the creationist literature.
No. I just have to correct you on that. No, like the papers I'm referring to are in secular journals. I'll post them in, because I don't want to just play our 15-minute video. We got all the sources there. When it comes to the nuclear DNA, I totally agree with you in the fact that the nuclear DNA would take us much further back than 6,500 years ago, which I'm saying the mitochondrial DNA takes us back to. But the question is, and I'll just, I guess, see how well you understand our position. The big question is, Aaron, is where does genetic diversity come from? Now, I know you guys explain the vast majority, if not all, the nuclear DNA differences as a result of mutation. Do you know what we explain the nuclear DNA differences, the millions and millions of nuclear DNA differences as?
Go ahead.
So the big difference then between my view and then the evolutionist view, for example, is that we explain the vast majority of nuclear DNA differences, not by mutation like we explain the mitochondrial DNA, but as pre-existing or created heterozygosity. So that one genetic difference, Aaron, has massive implications for, one, the timing as to the origin of species, the function of the genome. Okay, I would agree that if you're just trying to explain the origin of the species, or you're looking at coalescence calculations in mitochondria and nuclear DNA, just by mutations, then we're going to need millions and millions of years for all these differences to accumulate. I totally agree with you on that one. But if the differences are there from the start, I'm almost done here, the simple operation of recombination or even gene conversion and some mutation can produce visible variety in even a single generation. So that actually correlates perfectly with the coalescence time of mitochondrial DNA and the coalescence time of nuclear DNA.
So, trying to understand your position here. Are you trying to say like a heterozygosity, like some sort of perfect heterozygosity, where you have every single possible variant that could be expressed within the genome of Adam and Eve?
So by pre-existing functional heterozygosity, I would say that the DNA differences, the millions of DNA differences that we do see across species, I mean, we have DNA differences within our own genome, and then DNA differences between, like, for example, me and my daughter would have DNA differences in us. So I would say that the vast majority of those DNA differences were created as functional DNA differences. So yeah, they would be, there would have been tens of millions of heterozygous DNA sites at creation. That's why recombination and gene conversion, right, kind of like shuffling a deck of cards, could reveal genetic variants in just a single generation. But that's kind of a counter to your argument and statement that the nuclear DNA has a coalescence calculation that goes further back than the mitochondrial DNA. Go ahead, take as much time as you need there. I know I talked a lot.
So for one, I don't see how that would be different than the cryptic variation, which I was describing, that we know occurs. Also, I'm still not too clear. Like when we talk about heterozygosity, we're talking about allelic variations because we're diploid organisms. We have two versions of genes typically. Just trying to kind of hone in, be more precise about what you're trying to get at here. Let's talk about, say, hair color as a trait. For this perfectly heterozygous couple, are you saying that between the two of them, they would have alleles for every single variation and type of hair and hair color known to man in their genome?
Good question. So a lot of the variants that we see, for example, like blue eyes, for example, that, because we can look at allele frequencies, right? So the more rare an allele is, the more rare an allele frequency is, we can conclude that that was the result of mutation. Okay, so we would say that that was the result of mutation probably after Babel. Once there was the dispersion and a lot of people groups became isolated. But yes, the majority of them that I would consider design variants or just built-in alternatives that God would have put into Adam and Eve, I'm saying that all these built-in alternatives can be scrambled over time and therefore reveal new traits and new species quickly.
So for eye color, I'm just not sure why you would need that, because we know there's two different types of genes currently that produce a continuum of eye color across populations, and it's also related to hair color. So I don't see why you would need all this variation of. It seems kind of too simplistic. I don't know. I'm not following what you're. It doesn't seem to make sense with genetics.
Well, I'm saying with built-in alternatives, with this functional heterozygosity, I mean, we can see changes through, I don't know, we can see changes through homologous crossover, changes with jumping genes, right? These retrotransposons, the ALUs, for example, other mutation-related means as well. Recombination can generate diversity quickly. I mean, we can see the echo of this though in breeds.
You don't need perfect heterozygosity for novel variation to occur. Like, it's just not necessary. there's lots of other mechanisms to provide variation and novelty in phenotypes without having to have some huge swath of like some gigantic genome full of, you know, hundreds of thousands of genes, way bigger. I mean, I don't even know how Adam and Eve's genomes could have held all these variations. It wouldn't even been a human genome compared to what we have now. It would have been something totally different. So it's just not necessary. Like, look at the structure of, we know for a fact through experiments. Say you can take the hold on, let me try to think of the best way to explain this. Very minimal genetic diversity is required for large phenotypic diversity. And that's because of things that occur that aren't from functional, aren't from protein coding genes, like regulatory genes. It involve timing and place when something happens, how it's expressed, how much is expressed. You can take the limb bud from a chicken that's going to form like a bone or like a leg and transplant it to its head during development, and it'll grow a fully functional leg on its head. So it doesn't really take a bunch of genetic variation to create like novel traits. You look at the morphology of a bat wing versus a bird wing versus a pterodactyl wing. What do they all have in common? They all have the same bones. They have the same wrist bones and appendages. The bones are just in different lengths. Like you got the one for the pterodactyl, you've got, I think it's this thumb digit that goes way down here. So in development, bone is like a leading event that occurs. And then from that leading event, you have what's called exploratory behavior of muscle cells and nerve cells that will kind of all kind of shoot out in this exploratory behavior. So it's not guided. They just kind of go out in different directions. And once a nerve cell makes connection with the bone, then the other ones disappear. And that's the connection that's made. It's kind of like a fly flying around the house, lands on some fly paper, gets stuck there. And then that's it. There's no like, it was just randomly flying around and it gets stuck there. Or like ants coming out of ants when they come out of their nest, they have exploratory behavior. They're looking for food. They all go on various different paths looking for food. It's not like they have some plan or something. One happens to find like a dead cockroach, right? And now it comes back after eating the cockroach. It leaves a trail that the other ants can follow. Then they all kind of converge on that one trail, and that makes that one connection there, right? So in development, there's lots of different pathways where you can have lots of diversity form, like in different types of structures, like the wings and bat, birds, and pterodactyls that don't require a bunch of different coating protein genes and heterozygosity to occur.
Are you saying that there's a lot of function as well, and there's a lot of correlation between the non-coding DNA and the actual protein coding DNA, right? The regulatory elements when it comes to the function, when it comes to the changes within our genome? Is that pretty much in a nutshell what you're saying?
Yeah, a huge part of the genome is within like these regulatory regions,
right? I agree.
That have effects on these coding regions that code for proteins, for example. So they play a major part in developing the phenotypic diversity, especially like I said during development. You can just take the for example, there's an experiment done. I can't remember who did it. It was where they took the like the germ layer that forms the bottom side, like the belly of a eukaryote, and transplanted it to the back to see what would happen. And then actually it formed a completely separate embryo, like fully, differentiated into all the different cells, because all that information was there. It just depended upon the timing of those regulatory regions to kick in and make this occur. So very, very minimal variation is needed on the genotypic level to create lots of different novel phenotypic variation. You don't need created heterozygosity.
Well, I actually agree with everything you're saying in regards to those types of changes, right? The hidden information that can reveal these types of traits, and a major prediction based on the created heterozygosity model. For one, everything that you were describing, I believe, is consistent and actually helps our model out even more, actually. And when it comes to the created heterozygosity, I think to make it a little more simple and to keep it more genetically speaking, safe for the audience. I mean, as you were saying earlier with the alleles, right? It goes back to this idea of, you got the big A, big B, little b. So what I'm saying is if Adam and Eve and the created kinds were created genetically, let's say they were created genetically homogeneous, right? With absolutely no variety in their DNA, say all capital letters or all lowercase letters, then yes, I'm saying it's going to be difficult to create variety in just a few thousand years. So according to our model, we do look to created heterozygosity to explain the rapid speciation, for example, right? So let's say, let's use the kinds that God created, okay? Let's say he created them with capital A, lowercase a, capital B, lowercase b, and then you do that, Aaron, for the millions of DNA positions that actually exist in our genome. That means they have the potential to produce all sorts of variety in just a single generation. And then everything you said actually helps that hypothesis, because now we know the non-coding DNA, as you were talking about, it functions much like a computer. It's involved in regulatory functions, right? For the audience sake, that may not be as science-minded. That's just when and how fast to make specific proteins, for example. Embryonic development, the timings of protein manufacture. I mean, there's so much that's going on in the coding and non-coding regions, and even DNA elements, for example, such as the endogenous retroviruses, such as the ALUs, the retrotransposons. I mean, we're seeing more and more function, more and more ways to generate change in the genome. That's all consistent with this hypothesis that I'm talking about. And obviously we've kind of gone down a bit of a rabbit trail, because I was just trying to explain why the coalescence would be different in nuclear DNA versus mitochondrial DNA. I know I talked a lot there. Sorry, I like what you're saying, so I wanted to kind of piece it together, the bigger picture, right?
Well, real quick with what you're saying, and we can move on to chromosome number 2 if you want to, but like with what you're saying, with this created allelic variation of, it contains all the different the landscape of potential phenotypic variation. You don't leave any room for these regulatory regions to exist. You totally squeeze them out. So now you're gonna have to expand the genome of every single animal to these just vast proportions, and that's just based on a misunderstanding of how variation occurs and how novelty develops and how new phenotypes develop. So I can see where you're coming up with your idea, but I think it's just based on not a very knowledgeable understanding of how it all works.
Well, I mean, how much of the genome, both non-coding and protein coding, would you say is functional on, say, a percentage level?
I don't know, but I don't think it's relevant to what I'm saying.
Well, no, I believe it is, because from my understanding and from the literature that I've looked into and read, the evolutionary community, and I've actually debated many different scientists, Dr. Stephan Frello, for example, who's well known in this controversy, they will say the genome can't be any more than, and we're talking about regulatory elements as well, like you're talking about, any more than 15%, maybe max 20% functional. But we're saying based on this created heterozygosity model, nearly the entire genome is functional. Therefore, what you said about fitting all of that in the genome, for example, I think that that's based on an evolutionary assumption that the majority of the genome is based on evolutionary leftovers, genomic fossils, right? The pseudogenes, for example, the endogenous retroviruses. I mean, it was Richard Dawkins who said that 95% of the genome may as well not even be there. You know, all the parasites and things that are infested in the genome. But we now know that that is just completely false. I mean, paper after paper. I mean, are you aware of even these endogenous retroviruses that are shared among like humans and primates and is used as evidence for universal common ancestry? Are you aware of the accumulating evidence suggesting that they're incredibly important in the regulation of genes and determining cell types. I mean, just more and more function every day. It's amazing, actually. I love it.
Yeah, that's no surprise. You expect co-option to occur. I mean, this is the way DNA works. If you have, like I was mentioning earlier, the read-through stop codons they'll produce different variants of proteins that have different terminal ends, and some of those may be lethal, and so they're non-starters. They get selected out, but you have enough different variants that as soon as the selective pressures become enough, and you get enough of these buildup, this capacitance of these swaths of structural variants, then they can be selected for. Hold on, I lost my train of thought. What was the last thing you said? Sorry.
Well, just about the endogenous retrovirus, I do want to say, because I noted that you said that they were co-opted, but to be honest with you, I have to say that that's just nothing more than mere uninformative gloss, and I'll tell you why. Because the evidence shows that these endogenous retroviruses are incredibly functional, right? They have crucial functions that help regulate genes. They even help to determine cell type. So the evolutionists, and I read through these papers.
That's not a problem. It's a universal code. It's not a problem.
But the thing is, what I'm saying is, far from being junk DNA, as evolutionists have always assumed, right? Richard Dawkins, for example, have always assumed that 95% of the genome may as well not even be there. Now we know that the pervasive retrotransposons, the ERVs, for example, that populate our genome, they have a powerful capacity to influence genes and chromatin. So now the evolutionists, I'll read through these papers, and they go through all these various functions that are being discovered, and they always end it with, okay, these functions were co-opted, but these functions were not observed to be co-opted. And I challenge you to provide a paper afterwards that show an endogenous retrovirus going from non-functional to suddenly incredibly functional in embryological development. It's just not there. That's the evolutionist rescue device to explain away the evidence in the functionality of the genome. So I mean, if you have some papers that show these DNA elements, the co-option actually occurring empirically, then you may have an argument there. But I've never actually seen that demonstrated in these papers. Do you have any evidence suggesting they're actually co-opted other than just saying they're co-opted?
No, I'm not going to lie and say, yeah, I got this certain paper in mind that I'm going to produce, but it's not. I don't see any problem with it. I mean, you could have an ERV occur in a regulatory region that would affect, say, the production of like BMP, bone morphological protein, which would like inhibit certain developmental pathways, which could be lethal, but it could also create variation that could lead to some novelty as well.
Right.
And therefore that sequence that was where this ERV was kind of spliced in could then have some sort of new novel function within the genome. I mean, it's all the same base pairs. It's universal code, so I don't see any problem with these things being co-opted. Like there's no contradiction there. There's nothing logically impossible about it.
Right. I'm just saying that it's my position that because I read the literature, right? I read these papers on the functions of these, say, transposable elements, for example. I mean, they really are a incredible and important source. They're tightly regulated, they're biochemically active, and they are non-coding elements. I mean, this is a direct prediction based on the pre-existing heterozygosity hypothesis, suggesting that the vast majority of our DNA differences, the vast majority of our DNA elements are incredibly functional. I mean, they function in the transcription, in transcription factor binding sites and in non-coding RNAs. And I understand that you may have because I noticed a few words you said, like they could have, or maybe this, or maybe that. There's just, and I challenge even anybody listening in the audience, provide me a paper that shows a non-functional transposable element or a non-functional endogenous retrovirus suddenly going from the non-function to something that's incredibly important in, embryological development or immune response.
Well, I think you're also not realizing when you're talking about function, you kind of seem to have this black and white, like function, non-function, doing something important, not doing something important. But it's much more complicated than that. Genes have variations in the amount of their expression. So you could have a transposable element that does nothing at first, but then it can accumulate some mutations over time. And like I said, within a certain environment, it's cryptic variation that can be then selected for, and it can have some very minimal level of expression that has some sort of function relative to the environment. And it's not just some all function or no function, it's different degrees of function.
Well, and I understand that that's the evolutionary story and that's what you believe, but I definitely don't want to believe
empirically
it is a story because these very important functional roles in these DNA elements, the evolutionists just said they were co-opted. That's nothing more than storytelling.
Just get onto PubMed and look up papers that show variations in expression of genes and regulatory elements. You'll see a bunch of different papers written on it. It's not just so storytelling. I mean, this is empirical evidence that we do in the laboratory.
Right. No, and I understand your position. And I appreciate your response. I think because we have been going over for over an hour, if you want to, we can. I think because the only thing really that we haven't touched on that was talked about to make for a complete discussion would be the human chromosome 2 fusion. We could touch on that. And I
actually wrote some notes on that because I thought I was going to have like an opening statement, so I did jot some notes down. Before we were going to get together.
And I think that would probably be fun for the audience, fun for Tom. That's what it's all about, right? Having a good. I've had a lot of fun. Maybe this will be a good way to end it. We'd probably end it around the hour and a half mark, and maybe even set up another discussion because there's just you're right. There's just so many different things to.
Can you guys give me like 2 minutes?
Go for it.
Come right back, and then we'll just kind of wrap it up. I'll go over my notes on the chromosome 2, if that's okay.
Yeah,
beautiful.
Sure.
I think that's a perfect way to end it. So Tom, how we doing?
Good. Doing good.
You got any big debates planned soon?
I think so. I think I just set up like 6 of them yesterday, and I don't remember what they were anymore.
How many debates have you done? Do you keep track or?
I think I'm at like 70 videos on YouTube or something. I don't know.
Nice, good for you. Have you tried to reach out to like Answers in Genesis? I'd love to see you discuss. Testable predictions with Nathaniel Jensen. I know they're difficult to get a hold of and to schedule with, but have you reached out to them at all?
Yes, I think I reached out to them twice. I think one time I didn't hear back, and one time they said they were too busy. But they have a really complicated system that you have to use to get to actually email them. You have to specifically say, I want this speaker at this date, instead of just like, you just do a general inquiry as, are any of your speakers available to talk about blah, blah, blah. So they make it really complicated to try and go through the system to actually to get their speakers on board, which is difficult.
Yeah, it sucks because there's definitely a lot of scientists on staff there that I'd like to, see you discuss with. I think that's what's so good about Ken Hovind is he runs an independent ministry, so he's so easy to schedule debates and interviews and discussions. He's literally just a phone call away.
Yeah, I definitely like to talk with Behe and Myers and Dembski. Those guys I definitely want to talk to.
Actually, next Thursday, we're having Paul Nelson is his name. He works for, I believe it's Discovery Institute, or he works alongside Stephen Mayer, for example. So I'm going to interview him next Thursday, but if
you could actually ask him if he'd be willing to come on my show, that'd be great.
I will. Yeah. I think that would be an interesting discussion as well.
All right.
Actually, I'm just going to grab a bottle of water real quick. I see that Aaron's back. Just 1 second.
Yeah. So Aaron, would you want to give your brief introduction thing and then just go from there?
Yeah. You don't want me to wait for him, or I guess he can.
Yeah. We should probably wait for him so he knows what we're talking about.
Yeah.
Oh, yeah. I'm here. No worries. If we want to.
Okay. And so I just jotted down some notes. I hope it's not too long. I'll try and read through it really quickly. Hopefully it's all coherent. Just for my examination of human chromosome number 2, I think it's probably some of the strongest evidence we have for common ancestry, at least with humans and the great apes. So
right.
All right. So here we go. So as we know, like humans have 48 chromosomes, or humans have 46. The great apes have 48, and we know there couldn't have been a deletion event because that would be lethal. So there had to have been some sort of head-to-head telomeric fusion of two chromosomes in our ancestry that provide us with our 46. Kim Miller did a good job of going over this, and his Dover versus Kitzmiller trial, which kind of left creationists ever since then scrambling to try and find ways to deny this evidence, which is kind of funny to me. But so just some of the good evidence from it, the way that we know it's actually a fusion event, and so it has two centromeres whose surrounding sequences match up perfectly with the sequences of that in the ape pair, which is 12 and 13 in the great apes. The end of the telomeres, a repetitive sequence of TAAGGG, is butted up against CCC-TAA, which is to be expected from an inversion of the other telomere, which is predicted. The synteny and order of genes around this fusion site has been largely preserved. You can just go on to the ensemble.org, like I mentioned earlier, and look at it for yourself. You can look into this database and you can see that order. And you can actually see the genes surrounding the fusion site. I won't go over all of them, but on the left side, you've got a gene that's coded CBWD2, and then you got the fusion, and then to the right, the other strand, you've got gene RABL2A, and a whole list of genes that all match up on the opposite sides of this fusion site. And the genes to the left of the fusion site are found on one end of the chimp chromosome 2A, while those on the right they match 2B perfectly. Hold on a second here. So the chromosome 2 story is simple, it's clear, it's understandable, it's powerful, which is I think why creationists have scrambled to find ways to deny it. You'll hear criticisms of it. They'll say, like, in Sandy, you may present these. The telomere site is too short. Like a typical telomere has over 1,000 repeats, while the fusion site has less than 200. But that's to be expected, since one of the functions of the telomere is to prevent chromosome fusion. We know that telomeric disorders occur and reduce repeats. When this happens, fusion becomes much more common. You'll hear repeats are degenerate and don't perfectly match the TTA-GGG pattern. Some are 5 bases long, some are 7 bases long, but that too makes perfect sense. Telomerase is the enzyme responsible for producing the 6 base repeats, and that only works on the tips of chromosomes. Once they fuse, they are subject to changes that degrade and sorry, I can't read my own handwriting. They degrade the repeats. The mutation and recombination changes the number of repeats. Since the fusion occurred several million years ago, a degeneration pattern is exactly what we would expect to find today. Another claim put forth by the Institution for Curation Research is that an active gene, the DDX11L2 gene, spans the fusion site and therefore falsifies the fusion story. It doesn't. Go on to Ensemble, pull up chromosome number two, zoom in on it, look at it. It does not span the site. And this claim ultimately backfires anyways, in a most revealing way, because it's largely been abandoned now. The DDX11L2 is part of a family of pseudogenes, 18 in total, scattered around the human genome. Now guess where 17 of these 18 are located? Right next to a telomere on other chromosomes. The exception is chromosome number 2. Okay, and this is profoundly compelling evidence that it too was once part of a telomere, just as the fusion story demands. It gets even better though. Next to each and every DDX11L pseudogene is another gene designated WASH, W-A-S-H, located on the side away from the telomere. There's also one in the middle of chromosome number 2, next to the DDX11L and the fusion site, as to be expected. Finally, in every 18 locations on the human genome, the DDX11L pseudogene is transcribed in a direction away from the telomere, while the WASH gene is transcribed in a direction toward the telomere. The same is true for the copies of the genes near chromosome 2, the fusion site. In fact, every landmark surrounding DDX11L2 gene suggests that it was once located next to a telomere. And so this doesn't represent common creation, because all these different sequences I mentioned represent events in time that can only occur through common ancestry. I'm done.
Okay, so I appreciate that. I guess I do want to try and address everything you just said, so I hope I can have equal time here to do so. Okay, so just to be on the same page, Aaron is claiming that the human chromosome number 2 then arose by the fusion of 2 chromosomes in the hypothetical chimp-human common ancestor. So right off the bat, you would have had the split roughly 6 million years ago from the common ancestor of chimps and humans, and this so-called chromosomal 2 fusion would have occurred in the human line. Therefore, it would be indirect evidence anyways, as a chromosomal 2 fusion could have easily been passed on, say immediately post-flood or post-Babel, and actually, since we believe in a population bottleneck, could have been passed on quite easily. So I don't see it as very good evidence for universal common ancestry, since it can be explained in either model. So that being said, I will go on to the fact that, you know, fusions, they do happen in nature. So that's a fact. And therefore, the resulting fused chromosome can then be transmitted to the next generation. But it's also a fact that those fusions, those types of fusions that occur in the germline, they are very deleterious, right? They're going to reduce fertility. They're going to disrupt chromosome architecture, for example. Therefore, selection should be selecting against those types of events. I would say fusions in general are examples or manifestations of genetic entropy consistent with the fall, consistent with biblical creation. But here's the thing to consider. Most germline mutations, right, fusions that would have to be passed on, which is exactly what this type of fusion would have to be, they don't actually arise as end-to-end fusions, but instead they arise due to it's mistakes in the crossing over process. So I've got a lot of papers showing that chromosome fusions do arise within cancer cells end-to-end, which is what this, from what you said, it's an end-to-end fusion. But those that occur in cancer cells, Aaron, those are not transmitted to the next generation, obviously. Those are in the somatic cells. It has to be in a germline cell. So crossover fusions, they then result in the deletion of the ends of each fusing chromosome. So that means that the special telomere sequences at the ends of both chromosomes would be deleted, and any genes in the crossover region would also be deleted. So that being said, there wouldn't even be any trace of a sequence such as the reputed fusion site, right? Because no associated subtelomeric sequences, and then there would be no trace of internal telomeric sequences. But here's the problem, is that the so-called telomere to telomere fusion, it would have to occur in the germline, okay? Mm-hmm. When it was first discovered in 1991, it wasn't exactly what they expected. It had a different pattern, for example, than what was found primarily in living mammals, that it actually went through a chromosomal fusion, okay? Now, it didn't contain something called satellite DNA. So I noticed that that wasn't something that you mentioned, because yes, the telomeres are too degenerate, but you know, certainly that can be explained based on the shortening of it, because the telomeres, as you said, the telomeres are the end caps of chromosomes. They prevent fusion, right?
It does have the satellite DNA, by the way.
So is your position that the human chromosome 2 contains satellite DNA?
Yes, that's what's in the literature, and just pull up Ensemble, look at the human genome, and see it for yourself.
Well, because from my understanding, they find satellite DNA combined with satellite DNA in observed cases, or satellite DNA combined with telomere DNA, but telomere to telomere fusions, the one that's being purported in the human chromosome 2 is rarely, if ever, heard of or observed in I'm not talking about like cancer cells or, so it is your position that the human chromosome 2 fusion, the telomere to telomere fusion, satellite DNA was discovered? Because I haven't seen a paper that says that.
Yeah, it was. And,
well,
we know this has occurred. It happens commonly in human chromosome 13 and 14. There's family in China, lineage in China that has this fusion. People live and they survive and they produce children who have this fusion of head-to-head fusion, telomere fusion of chromosome 13 and 14. So it does occur.
Well, I'd have to see the actual paper demonstrating that satellite DNA was discovered in the human chromosome 2 fusion. I am going to say that it wasn't. But even those internal telomeric sequences that you were talking about, right? Because the telomere regions, the remnant telomeres that should be found, they are highly degenerate. Okay, they're a lot smaller than should be because telomere sequences. Yeah, no, but
should be expected.
But yes, I understand that you're saying that should be expected, even though telomere sequences are what, between 10,000 and 15,000 sequences long, like base pairs long. Because you're saying because it happened 6 million years ago.
No, over 1,000 or so.
Okay, so
at the fusion site, the telomeric region repeats are about less than 200.
Right, and I'm saying that those internal telomeric sequences that are found, like I think it's 800 bases in length, for example, or even 700, and I think it's only like 70% similar to what would be
it's less than 200.
Right. Okay. So you do agree that it's highly degraded, but you're saying that this should be expected technically.
Right. Yeah, that should definitely be expected. If it wasn't that way, then that'd be weird. We'd have a problem.
Here's the thing, though. Those internal telomeric sequences that they actually look to and say, okay, here's the remnant telomeres that are highly degraded, they're actually found all over the genome. And there's many papers, and I can send them or post them afterwards, that have been published that have given us functions for many of these sites. For example, they're binding to things called, as you know, transcription factors, which then initiate the copying process of a gene into RNA. So that's not just unique to the human chromosome 2 site. So the fact that it's degraded and then they've tried to explain it away,
you're wrong. The TT-AGG sequences, repetitive sequences, are only found on the tips of chromosomes, and the wash genes are only found right next to those that I mentioned earlier. The DDX11L2 does not span the fusion site.
Well, real quick, before you go on to that, what I'm saying is, those internal, are you disagreeing with the fact that those internal telomeric sequences that you're pointing to that are seen as highly degraded in the human chromosome 2, are you saying that they're not found all over the genome with important functions?
No, the telomeric repeats are only found at the tips of chromosomes. That's the only spot they're found. And that's the same place the DDX11 genes are found only at the tips of chromosomes. The only anomaly is in chromosome number 2, right there in the center where it shouldn't be. And what's next to it? Wash gene, where it also shouldn't be. What else is there?
But you're only looking, but with these so-called remnant telomeres, you're only looking at something that is, well, you're saying 200. I thought that it was, okay, so the fusion site is 798 bases, but you're saying the remnant telomeric sequences are about 200, right?
About 100, 150.
Well, for one, I mean, the reputed fusion site being only 798 bases seems to be an extremely tiny signature for such an event anyways. But I'm saying that those 200 sequences, those sequences that you're looking at, I'll probably just have to provide some data after the fact. Maybe you haven't heard of it. But those internal telomeric sequences you are pointing to as evidence for remnant telomeres are actually found all over the genome with many important functions. For example, the transcription factor relating functions. So that is not, and you mentioned I think it was the centromere, the cryptic centromere site, But that, which you should find, obviously, one would have to be deactivated if there was a chromosomal 2 fusion, Aaron. That would be lethal, of course. So that should be found. I agree.
Yeah, one's dominant over the other. That's what typically occurs in fusions.
How many? So this cryptic centromere, how many bases?
It's not cryptic. It's just a inactive.
Deactivated. Okay, so a deactivated. How many bases is it that they've pointed to as the remnant centromere or deactivated centromere?
I'd have to go onto the database and look. I don't know.
I think, from my understanding, I don't have notes on it here, but I believe it's less than 200 as well. So that itself is also very small. But that, and I understand you were talking about the the reputed fusion site being spanned by a functional gene, but I'm not even going to point to that right now. The cryptic centromere, or the deactivated centromere, as you'd want to call it, it's way too small, for example, that region. It's too human to actually be a remnant centromere, and this entire
human lineage.
Well, just 1 second. Here's the big thing. That entire sequence is internal to a functional gene, and I'm talking about the so-called deactivated centromere. So that would be impossible if the deactivated centromere sequence was ever a real centromere, as it would have had to be if it was a chromosomal 2 fusion. So, I mean, how do you explain that fact?
I've never heard that one. I'd have to look it up. I don't know. Never heard about a gene spanning the centromere. That's what you're saying?
Yes. Yeah. I'll send you the I'll send you the paper on that. I want to say
I would assume it's like the claim that the DDX11L2 spanned the fusion site when it didn't. I mean, I know that there's millions of dollars involved in trying to figure out ways to deny this, and paying these PhDs who don't have relevant degrees to try and find a way to discredit this. But statistically, too much adds up. Like, how do you even explain the simplicity of moving from where the fusion site, moving from TAA-GGG, but it directly up against CCC-TAA? How does that occur?
Well, before I go on to that one, because you were saying that it doesn't span the fusion, are you using Ken Miller's argument that it doesn't span the fusion site?
I'm using my own eyes to go onto ensemble.org, pull up human chromosome number 2, and zoom in and look at it for yourself.
Right. So that exact argument, and just because, for lack of time and also for lack of just going on, Ken Miller used that exact same argument, and him and Dr. Tompkins, Jeffrey Tompkins, they had a back and forth through email. And Miller, he attempted to explain the longer transcripts of the DDX11L2 gene. In the paper, what does he say? He says that it's easily explainable by variability in the termination of transcription, so that occasionally a somewhat longer RNA is produced. And he says that, let me see here. He goes on about how you're saying that it's not actually spanning the fusion site, like the functional gene, for example. And Dr. Tompkins goes over why that's wrong in this paper, that instead of just reading off, I would probably just send it after the fact and kind of see what because Dr. Tompkins talks about how the longer transcripts begin ahead of the fusion site at the 5' end of the gene, and that it's well documented fact that transcription begins at the 5' ends of genes. So he's pretty much just going into the fact that it really does, this functional gene does span the fusion site. But I just have to urge you to maybe read that paper and see it's a newer paper, so I don't know, maybe you haven't seen it yet.
I apologize, just to interject for a second. The people in the chat are saying that, Standing, you're getting a little loud. Could you talk a little bit quieter to try and balance out the volume a little bit?
Oh, yeah, sorry. Am I just getting loud now?
Yeah, you've been getting louder for the past 3 or 4 minutes. I think it's just you're getting more energetic or something. So it's not.
That makes what he says more true.
Yeah, the louder and the okay. Well, I will say this: it is getting kind of late. It's been a lot of fun. We can do a couple more of these. Did you want to kind of sum up your position on that, there, Aaron, and then we can kind of go from there?
Yeah, I mean, it's to me, it's the cumulative case. Like, there should be no reason for all the other features I mentioned to perfectly match up from chimp chromosome, ape chromosome 13 and 14. If you flip them around, there should be no reason why we should see the exact same sequences meet up in the middle of human chromosome number 2 with the exact same genes flanking the fusion site. If common ancestry makes perfect sense of this, creationism, it's an utter mystery. It's just a complete mystery, and you have to just, scramble to conflate some sort of stories to.
Sorry to cut you off, because Aaron, you were saying that the sequences that flank the reputed fusion site, they should match up with sequences near the ends of the corresponding chimp chromosomes. And you're saying,
like I said, and like I said, even the telomere sequences, the CCTAA that flanks, that comes off of butts up directly to the TAA-GGG from the left side. There's no other explanation for that, other than it's a fusion, and unless you want to say that's just you can always appeal to God, say that's just the way the designer made it, and he's trying to be deceptive if you want to, but just to make it to fool us for some reason. But I just don't see any reason for that to be the case.
It's my understanding that the ends of the two corresponding chimp chromosomes that we're talking about, they haven't yet been fully sequenced. So if they haven't been fully sequenced, and then the actual region that contains the reputed fusion site,
they have
DNA.
On the left
real quick, because that region that contains the reputed fusion site that we're talking about, that you're saying is derived from 2 ape chromosomes, now appears to be DNA that is uniquely human and then is absent in all ape genomes. So there's not this perfect synteny as you were.
No, there is. I actually went on Ensemble earlier. I wrote down 4 genes to the left, 4 genes to the right of the fusion site. You've got ILIRN, and then you've got PSD4, and then you've got PAX8, and then you've got CBWD2. Then you've got the fusion. Then you've got RABL2A. Then you have SLC35F5. Then ACTR3, and then DPP10. And these all match up perfectly with the chimp chromosomes near the telomeres on both of the separate chromosomes.
Yeah, if you could send me, because I think in regards to the chromosomal 2 fusion, we're definitely going to have to send each other some of the things we're discussing. I'll send you the paper I was talking about. But it's my understanding that entire region of human chromosome 2 doesn't actually appear to have homology with any part of the 2 chimp chromosomes that are actually being said to have fused. But that region, and it is a very sizable region within the human chromosome 2, only aligns with various other chromosomes of the chimp genome. I think maybe like chromosome 9, for example. So there should be more so perfect homology and synteny. And I understand that you're disagreeing with what I'm saying in regards to the synteny, but that's my understanding. And we may just have to exchange some papers after the fact. But I do want to say, I believe that there are some discrepancies based on satellite DNA, degenerate telomeres, the so-called deactivated centromere. But that being said, I'm also open-minded to there being an actual chromosomal 2 fusion, because that's why I started off my section on this, I guess, by saying that fusions in general are manifestations of genetic entropy, and we could easily explain a chromosomal 2 fusion in the human line post-flood, post-Babel, especially because we believe in a bottleneck. So I think either way, if there was a fusion, it's indirect evidence, and therefore it's agnostic to the debate. That's just my position on it.
Yeah. It still doesn't explain why we have the same exact ones in the ape chromosomes that match up perfectly. That shows history. That shows a history of events occurring in common ancestry. That's the only way it can be explained.
Well, I'm saying that the synteny is not lining up perfectly. Plus, we also know that synteny, right, like the gene order and the architecture of the chromosome, are also playing in very important functional roles across different species. So there's so many multiple overlapping codes in our genetic information system. There's so much hidden information, compressed information. So, it's my position that we understand very little of the DNA language, and a lot of the best arguments for universal common ancestry, whether it's the human chromosome 2 fusion, pseudogenes, endogenous retroviruses, for example, or DNA level nested hierarchies, I believe that that's all being thrown out with the junk DNA paradigm, because more and more data suggests that our genome is incredibly functional, and I believe that that's all consistent with our model of created heterozygosity. So I mean, I definitely don't want to beat a dead horse there.
Yeah.
I appreciate you doing this discussion. I'd like to give you the last words on it, and then maybe in the future we can set up another discussion, because it's been a lot of fun, Aaron. How much of the genome, both non-coding and protein coding, would you say is functional on, say, a percentage level?
I don't know, but I don't think it's relevant to what I'm saying.
Well, no, I believe it is, because from my understanding and from the literature that I've looked into and read, the evolutionary community, and I've actually debated many different scientists, Dr. Stephan Frello, for example, who's well known in this controversy, they will say the genome can't be any more than, and we're talking about regulatory elements as well, like you're talking about, any more than 15%, maybe max 20% functional. But we're saying, based on this created heterozygosity model, nearly the entire genome is functional. Therefore, what you said about fitting all of that in the genome, for example, I think that that's based on an evolutionary assumption that the majority of the genome is based on evolutionary leftovers, genomic fossils, right? The pseudogenes, for example, the endogenous retroviruses. I mean, it was Richard Dawkins who said that 95% of the genome may as well not even be there, all the parasites and things that are infested in the genome. But we now know that that is just completely false. I mean, paper after paper. I mean, are you aware of even these endogenous retroviruses that are shared among like humans and primates and is used as evidence for universal common ancestry? Are you aware of the accumulating evidence suggesting that they're incredibly important in the regulation of genes and determining cell types? I mean, just more and more function every day. It's amazing, actually. I love it.
If you have, like I was mentioning earlier, the read-through stop codons they'll produce different variants of proteins that have different terminal ends, and some of those may be lethal, and so they're non-starters. They get selected out, but you have enough different variants that as soon as the selective pressures become enough, and you get enough of these buildup, this capacitance of these swaths of structural variants, then they can be selected for. Hold on, I lost my train of thought. What was the last thing you said? Sorry.
Well, just about the endogenous retroviruses, I do want to say, because I noted that you said that they were co-opted, but to be honest with you, I have to say that that's just nothing more than mere uninformative gloss, and I'll tell you why. Because the evidence shows that these endogenous retroviruses are incredibly functional, right? They have crucial functions that help regulate genes. They even help to determine cell types. So the evolutionists, and I read through these papers.
It's not a problem. It's a universal code.
But the thing is, what I'm saying is, far from being junk DNA, as evolutionists have always assumed, right? Richard Dawkins, for example, have always assumed that 95% of the genome may as well not even be there. Now we know that the pervasive retrotransposons, the ERVs, for example, that populate our genome, they have a powerful capacity to influence genes and chromatin. So now the evolutionists, I'll read through these papers, and they go through all these various functions that are being discovered, and they always end it with, okay, these functions were co-opted. But these functions were not observed to be co-opted. And I challenge you to provide a paper afterwards that show an endogenous retrovirus going from non-functional to suddenly incredibly functional in embryological development. It's just not there. That's the evolutionist rescue device to explain away the evidence in the functionality of the genome. So, I mean, if you have some papers that show these DNA elements, the co-option actually occurring empirically, then you may have an argument there. But I've never actually seen that demonstrated in these papers. Do you have any evidence suggesting they're actually co-opted, other than just saying they're co-opted?
No, I'd have to. I'm not going to lie and say, yeah, I got this certain paper in mind that I'm going to produce, but it's not. I don't see any problem with it. I mean, you could have an ERV occur in a regulatory region that would affect, say, the production of like BMP, bone morphological protein, which would like inhibit certain developmental pathways, which could be lethal, but it could also create variation that could lead to some novelty as well, and therefore that sequence that was where this ERV was kind of spliced in, could then have some sort of new novel function within the genome. I mean, it's all the same base pairs. It's universal code, so I don't see any problem with these things being co-opted. Like there's no contradiction there. There's nothing logically impossible about it.
Right. I'm just saying that it's my position that because I read the literature, right? I read these papers on the functions of these, say, transposable elements, for example. I mean, they really are a incredible and important source. They're tightly regulated, they're biochemically active, and they are non-coding elements. I mean, this is a direct prediction based on the pre-existing heterozygosity hypothesis, suggesting that the vast majority of our DNA differences, the vast majority of our DNA elements are incredibly functional. I mean, they function in the transcription factor binding sites and in non-coding RNAs. And I understand that you may have a story, because I noticed a few words you said, like they could have, or maybe this, or maybe that. There's just, and I challenge even anybody listening in the audience, provide me a paper that shows a non-functional transposable element or a non-functional endogenous retrovirus suddenly going from the non-function to something that's incredibly important in, embryological development or immune response.
Well, I think you're also not realizing when you're talking about function, you kind of seem to have this black and white, like function, non-function, doing something important, not doing something important. But it's much more complicated than that. Genes have variations in the amount of their expression. So you could have a transposable element that does nothing at first, but then it can accumulate some mutations over time. It's cryptic variation that can be then selected for, and it can have some very minimal level of expression that has some sort of function relative to the environment. It's different degrees of function.
Well, and I understand that that's the evolutionary story and that's what you believe, but I definitely don't want to believe it is a story because these very important functional roles in these DNA elements, the evolutionists just said they were co-opted. That's nothing more than storytelling.
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.